It is video 181. It's Monday. I just want to make absolutely sure I have that correct, because a lot of times I record and then realize the serial number is wrong and then I have to scrap the video. So yes, video 181. This comes directly after the video of Tom's photos. We're working on user interface rectangles for the game engine, trying to get just a rudimentary UI in. I hate working on UI. But I just need something bare bones basic in here so that I can click it. So before we go there, let's we're gonna make our way to Discord really quick. We're gonna make our way to Discord, and we're going to we're gonna go check some stuff really quick, and then we're gonna check chat. So judging by how slowly Discord is working, I'm going to guess I'm screwed on internet speed again, so no one's going to be able to watch this. Oh, yes. Yeah, so in Discord, Don Ho had posted something about Flat Earth, and so I started just posting Banana Earth memes. Anyways, so anyways, let's go to our dashboard, see if anybody has said hello, because I really should do this earlier, but I don't know what I'm doing. And also, let's change these stream titles. So let's try to keep up with this, right? So we're on video 180, right? And it's actually going to be Uirects, and if we do game engine go live, probably no such thing. Let's make a shortcut for that. So we got like a lot of crazy shortcuts here. But let's make like a go live message for game engine stuff. So game engine go live. Game engine go live. Okay. So make some shortcuts, and then sure. Sure, why not? We'll take it. We'll take it. We'll use something like that. And we'll just put that in the go live notification. And then we'll say done. And I guess technically it's not sculpture this time. Let's not worry about it. Let's just keep that category, because the category for sculpture does apply sometimes when we're doing the Decton stuff. So let's move this over here. And let's just start hacking away here. This is Monday, so we have some coffee. Yeah, so Windows E key, AAC 2020 folder, and the first thing we want to do is just we want to Hold on. I'm just making notes, doctor notes. I'm just taking down some notes from my doctor, or notes that or questions I have from my doctor next time I have a doctor visit. I gotta put that down. I'm closing some files on my other monitor. I had to file my earnings report for my corporation. I haven't earned anything, but I still have to file it, otherwise the corporation gets dissolved. I have a doctor's appointment. So I just want to make some notes of those things before I before I get situated here. Context switching sucks. Context switching has a cost, and we can see what that cost is because we're streaming, and we can see we're 7 minutes in and we haven't started yet. But we've gotten more stuff situated, so that's good. So lib, we're gonna go find Uirects, and looks like we just have the data file, and it looks like we're working on the concept, but we haven't really stubbed it in yet. And we're trying to figure out, like, how the heck are we gonna make a very simple UI? And I was thinking, you know what, we should probably just keep it like a 7-letter kind of thing, you know, and then if we do that, and every character is 16 by 16, right? Then what does this get displayed as, right? So let's look at that for a second. So 16 times 7, right? I don't know why I got pi. What? Oh, wait, what the hell is wrong with my browser here? Hello? Seems like Google is trying to be cute. But that's just kind of annoying because now I can't see. God. 16 times 7 looks like 112. Maybe I should use a real calculator rather than a search engine. But yeah, 112. So that sounds about right. Right, so let's just look at that for a second. Okay, right, so this is 32, this is 64, right? And then if we add another 32 to 64, we get what, 94, right? 94, and then 94 plus another 16. My math is off by 2 because I get 100 and I get 110. So somewhere I made a mistake. I'm pretty sure that 112 sounds about right. Okay, so we know it's 112. We're going to use perfect squares, I think, just because I don't know if a perfect square is the way to go. We could use 64 by 64, or sorry, not 64. This is, geez, this is 16. We could do this, or we could, decide to make it a little bit bigger, give us a little bit more room. But 112 pixels is already kind of pretty clunky. Unless you want to use kind of half-sized, right? Like if we want to use like character glyphs that are half the size, right? So if we want to do like if we go into Paint and we look at like what we could manage, like square characters, square characters are kind of a little bit big, right? Because I think we could get away with like 8. We could get away with like 16 by 8, right? Because then we can draw things like B's, right? So a B needs some resolution. Z is a little bit difficult to draw, but I think we could manage it, right? Where, right? So we could. So I'm almost thinking something like maybe 10. Actually, maybe like 9 by 16. 9 by 16. Because then it just makes it a little bit easier to write something, because now there's an exact middle, right? There's an exact middle if it's odd, and that just makes this whole process a lot easier, right? Because then we can just go, boom, we have a weird-ass Z, right? Or maybe we want to do something like 9 by 9. Or maybe we just want to think about the graphics and be like, hey, why not, this isn't 9 by 9, what is this? 9 by 11? So it's like, okay, yeah, we could do that, but then the problem is like, how the hell are we gonna remember that we're using 9 by 11? And that doesn't really fit into textures very well. It wrecks our whole power of 2 thing. You know, the more things we do with power of 2, the more happy coincidences we have. So we're limiting ourselves for happy coincidences that we're not going to be able to predict in the future, right? So as much as I like this, maybe 8 by 8 is enough, right? Maybe 8 by 8 is enough for drawing all the glyphs that we want. And if we want capitals, we just do some in shader processing to put like some type of square around the graphic, right? Rather than creating upper and lowercase letters. So if we did something like this, that looks more like a 2. I guess that could kind of be a Z. Yeah, I mean, maybe we could make it work. Maybe we could make it work and do 8 by 8. Right? Now, if we're going to do 8 by 8, we should probably make a glyph thing for that, right? So let's think about the calculator for a second. Calculator. And let's think about what we have, right? So we got 26 letters plus 0 through 9 plus 10 kind of other things. Okay, that's 36. And then plus, let's say just 48, right? Oh, actually 32 after 2, 4, 8, 16, 32, 64. So let's just say 64. 64 glyphs, right? Now for 64 glyphs, we need like an 8 by 8 kind of texture. And so 8x8 texture and 8x8 cells to get 64 cells total. And since everything is 8, it's a 64 by 64 texture. Okay. So here's what we're going to do. We're going to do 64 by 64. Okay. And then what we're going to do is we're just going to paste this here. And so it's 8. Okay, so there's 8 here, there's 16 here. So that would make over here 17, right? 17, 18, okay, 19, 20, 21, 22, 23, 24, I'm bad at math. This is 25, and this is 26. So this is the slot where we would have... this is the slot where we would have our Z, right? If we do... if we kind of, like, start here, right? Now, the other thing is, well, what about like, 0 through 9 is kind of, like, makes more sense to be at the top, just because the fact that we don't have to think about any of the math involved with that. So I'm thinking, let's go take this 8x8 here. Let's go over here. And we have some texture memory that we're not using, so maybe we could throw this into the tau, right? We could throw this in one of the tau blocks. Image, canvas size for a second. Right, we got 64 by 64, so we would actually need... if we want this loaded into the tau system, right, if we just want to co-opt some of that memory, right, if we go look at taudump.data, right, we got to co-opt, so each one of these blocks here is 32 by 32, right, right, this is a 32 by 32 block, right, because this would be 64 by 64, actually, I'm wrong there, hold on. 128. Oh, because we're inside of here. Okay, yeah. So we could... right now we're using this thing in tau, right? So what we could do is we could make another block called... so this block is called tau. This block here, 14, could be called graphics. And or Uirects or UIR, right? 14 could be like UIR, and instead of subdividing it this way, we could just, we wouldn't even use it for the same stuff, right? We would just, not ever flag that section as dirty, right? It would just be kind of a static memory allocation. But if we're doing that, then maybe we want to back off and maybe put it at 0 over here. And try to keep the static memory like maybe keep the static memory over here if we can, and keep the non-static memory over here. That way when we're doing texture pushes, maybe it'll be more optimal. I don't know. But yeah, I'm thinking we just use one of these blocks as the UI rectangles, right? And yeah, I think that could work. Yeah, we just give it a different chunk, and we just use its memory. We just co-opt its memory. 'Cause we got this big chunk of memory. And this chunk here is for all the, right, we have 32 by 32 chunks of memory in here for the different systems. So why not? So we have like 14 different blocks here that we don't even know what we're going to do with yet. So it would make sense to me to just co-opt that. Alternatively, it could be nice to pack everything nicely here, because then we can figure out we can shuffle things around later. Or just make it flexible enough that we can move what block it is later. But yeah, we could put the memory kind of here. Okay, so anyways, let's just kind of develop some glyphs here. Right, so we're going to do like a 0 through 9, right? I don't know which way the slash has to go for a 0. Okay, so some of the graphics here are going to kind of suck, right? The idea right now is just to get something basic. Also, if we keep it as image glyphs, then we can so 32 and 32, 32 bits in a pixel, right? So if we kept this completely black and white, and we want 64 of these, we could just have 2 glyphs that just have everything bit packed together. And that would be nice. 1, 2, 3, 4, 5, 6, 7, 8. We could, if we did that, 1, 2, 3, 4, 5, 6, 7, 8. We could try to, yeah, I mean, that could be very helpful. Okay, let's not worry too much about that for now. Let's just get these glyphs into the code somewhere. So I was thinking, hey, instead of getting the glyphs into the code as data, we could hard code these assets, right? But I'd rather not do that. So let's oh, cool. So since we have so this is going to be a 1. So it needs a little flag here. And it needs a little foot. Okay. And then for the 2, actually, no. That's fine. Let's copy this over. And then for a 2, let's just draw a 2. This is an interesting way. Can we get away with that for everything? Actually, we could, right? We want to know that our numbers are numbers. We could just do this. Give this kind of style to it. And then here we can just, right, so that's a 0. Oh no, let's have fun with that. Let's see where that goes. Alright, so this is like a 3. Oh boy, that gets hard to read. Because we have absolutely no padding right now. Okay, then over here, we'll make a 4. Let's just steal this one. Let's steal this one. And 4 maybe like that. I don't know. Could write our 4 like that. That's a weird looking 4. Okay, here's what I'm thinking. To be able to see this better, I'm thinking that we can make every other color. We can use first of all, let's color all this red. Let's get rid of the anti-aliasing really quick. So turn off anti-aliasing and let's just flood fill all this with red for a second. Okay. Then let's go over here, let's flood this with black. Oops. Okay. And now let's just use like red and green, right? Or let's be nice to people who are colorblind. Let's use... so the idea is that for any... black is nothing, and then if it's anything besides black, it's set bits, right? So we're trying to make kind of this binary mask of colors. Right? So this way we can see the borders between them easier, right? And so we can pack this asset into the engine source, and we can use this asset to create the final map. So that's my thought on how this is gonna go down here. So let's steal this for a second. Let's copy this and put this over here. Alright, so this is gonna be 5. And for 5, we will... so this other color here needs to be like this. Okay, there we go. So... okay. So for 5, we'll do the same kind of thing where we have this kind of big top here. And then we'll try to round that a bit. Oh, I see, we did kind of like that. So it'd be more like this. Okay. And then let's just keep going. So let's copy the red one now. Or actually, let's put something somewhere where we can just have a black canvas to copy over, so we don't have to keep on cleaning it up. Okay. Okay. And this one is going to be our 6. So I don't know exactly how that needs to look, but if we want to continue with this crazy style of... right, if we want to continue with that kind of style, then we can do that. And now the 6 and the 5 look too much alike, right? So I'm thinking in order to tell the difference, right, we draw it like slightly different. Also, I noticed that these other numbers have like a double thick edge right here. So if we want that, I think we should kind of do that over here. And then over here as well, we should have kind of like this double thick edge for consistency with the whole font, right? So the 5 and 6, we just want to draw them slightly different. And then let's do 7 now. All right, so 7. Doesn't really matter what color we have here for the other color, just as long as we can distinguish the divisions between the different glyphs by using different colors, right? That's the only reason I'm using these different colors, is so that as I'm drawing this, I can be like, oh yeah, I know what I'm doing here, right? So okay, that's maybe not the best 7. I mean, we could try to thicken that out a bit, right? Maybe that's a better 7. I don't know. Let's just go with that. Let's not worry too much about it, right? Let's just kind of keep on doing stuff. So, double thick, and then so I'm trying to keep the same kind of format. So this would be an 8 in the style of these other numbers. And maybe we want to round off some of this stuff, right? So the 8 has a little rounding on it. But the other numbers don't, so maybe we don't do that for now, right? Also, that was the one that I was supposed to keep black. Can we just do this? Just do this, fill it with some black. Okay. And now we're just going to make a 9. And we're going to try the same kind of style as... We're going to try to keep these stylistically the same, right? So our 9. We also don't want the 9 to look like an inverted 6, so our 6 and our 9 look sufficiently different. Okay, so we got 0 through 9, and then we wanted like an A through Z somewhere, right? So we have 8 and 8 is 16. Then we got 24, and then 25 and 26. So this is the allocation we're going to need for the A through Z. So we put it all here because we're like, hey, wouldn't it be nice if it started at some type of sensible offset? I don't know if that's actually helpful or not. I'm thinking we just throw them next to each other here, right? So 0 through 9, and then after 9, it's just A through Z, right? In the index order. I think that might just make it easier to comprehend what's going on here. So I'm thinking, you know, here A is over here, right? And then we got A, and then actually let's I wish I just had MS Paint so that this would be easier to do. But let's just do the let's try to target some of the every other letters so that we can streamline the process of drawing out these glyphs. And we're just going to work on lowercase. So uppercase is just going to be like, we'll do a pre-processing step when we render, and just put like a rectangle around, we'll put a little rectangle around the letter if it's uppercase or something like that. Or if we need to distinguish between uppercase and lowercase, we'll do some type of trickery. But I don't want to have to draw both uppercase and lowercase glyphs. Let's just keep everything, you know, one style. Okay, so let's just grab our pen tool here and let's start drawing out some letters, right? So let's try to do kind of a thinner style. So these are our letters. Our letters have a different style than the numbers. So let's just try something nice and thin and sleek. A, B, C. So this is a C over here. Now, do we want like little teeth on it? Sure. A, B, C, D, E. Okay, so here's E. And in the middle, that's a little bit too much. This is a little bit too much here. E. Okay. E, F, and then G. So G is over here. G, H. So this is H. And before we get ahead of ourselves, there's always the potential that we've made a screw up here. So let's look at that again. A, B, C, D, E, F, G, H, I, J. Okay, yeah, we're still good. Okay. J, K, L. Okay, M, N. Also, remember that I really don't care too much about, oh, does this look good from an art perspective, right? I don't really care about that. It's mostly a, hey, can I understand what these letters are? L, M, N, O. The other thing is this O needs to look sufficiently different from this, right? So I'm thinking we should probably make it like a little bit taller, like this. And then we could round it like this, and that's an O, right? L, M, N, O, P, Q. So Q also we should make different. Since we only have one case of letter, we might actually just want to choose to draw it in a lowercase-ish kind of style. I don't know. Q. R. Q, R, S. So S over here. Yes. S, and then we're doing like a double thick thing in the middle, or what do we want to do here? With the A, we didn't do that, right? With the A, we didn't do that. So we have this kind of extra thickness horizontally for the numbers. So maybe we shouldn't do that for the letters. Maybe for the letters, we could do 1, 2, 3, 4. 1, 2, 3, 4. So if we want the H to be consistent with the A, something like that. And then over here, 1, 2, 3. We want this line here to be, okay, so if this was an E, we'd go like that. I don't know if that looks better or worse. Maybe we shouldn't be worrying about this too much. The S is kind of consistent. The E and the S are consistent. Okay, Q, R, S, T, and U. So for the U, once again, we are thinking that maybe we want to keep our letters kind of like sleeker than the numbers, right? So with that, we might want to refine this a bit. Make that sleeker. And then same thing with the L. Might want to make our L kind of smaller. The J, same thing. We might want to. It's an even texture. It's even number of pixels. So it's like, well, which way do we go? Do we lean towards the left or the right? Well, the L is already leaning towards the left, so that would mean that the J would also lean in that direction. Just for consistency. S, elemental P, Q, R, S, T, U, V, W, X, Y, and Z, right? So let's steal this. And there's X, Y, and Z. So let's kind of just erase this for now. And also, we can just copy this, right? We already know what Z looks like. Z is this thing right here. Okay. Or for now it is. Maybe we'll change our mind on that. Also, this is backwards, right? We can't actually have it that way because we decided that black is nothingness, and then colored pixels are our 1 bits, right? So we're going to pre-process and bitpack this all together to save some space. So it's actually going to be this, or something like this, and then also the background itself has to be a black. My bad. Okay, so now that we have this, the next thing I want to do is I want to go through here and copy this, and I want to start filling out the other missing letters, right? And also put that 2 in. I don't have a 2 yet. So the reason I'm going with 8x8 rather than 16x16 is it's the smallest power of 2 that I think I can competently make a 0, 1 kind of 8. It's the lowest resolution that I can use 2-bit color with. Or sorry, it's the lowest resolution I can use 1-bit color with. And be able to know what the heck those symbols are. So that's why I chose 8x8. So now let's just fill everything out, right? So this is going to be, this is a 2 over here. Right, so same style, right? So the 2 and 3 have the same kind of style. Okay, so A and B, so let's put a B here. And I know we need to, oops. We need to like round this or whatever. With the B, is the bigger part on the top or the bigger part on the bottom? I think the bigger, well actually it doesn't matter because this line is here. We want the line to be consistent, so it makes more sense for the line to be like that. B. Okay, then D. Okay, A, B, C, D, E, and F. Let's try to make the F just kind of like the E, except, you know, not the bottom leg, right? So A, B, C, D, E, F, G, and H. So G kind of like this, right? We want that midline to line up with the midline in the H. I do kind of like that, but G, H, I. Also, we're going to lean towards the left for these things, so I. J, and then K. I don't know how we're going to solve this one. I'm going to go towards the bottom. We want that leg to be a little bit bigger. Or is that backwards? Looks a little bit backwards to me. Um... Okay, actually, no. Let's do that other one. It looks kind of in. It looks kind of upside. It looked kind of upside down, but the proportions weren't too bad. Oh yeah, it's because this midline is here. So by that happening, that's just the shape it's gonna have to have. Okay, I see. J, K, L, and then M. Let's do M, N, O, and P. Hey, I'm, yeah, let me show you. Let me show you the engine, because it's not much. It's not much, but I can actually show you what that is now, because that is, yeah. So okay, cool. Yeah. Well, my stream can be kind of unpredictable. I really need to get an Ethernet code. An Ethernet cord. Too many people moved into this house, and so the Wi-Fi just kind of sucks right now. Right, so if I want to get, like, priority access to the internet, I need to, like, wire myself in. But yeah, let me just show you the, so I'll be coding probably for, like, 16 hours today, with, like, a 3-hour break in between, because I have to go to the machine shop at some point in time today. But today is the only day I drink coffee. So I don't drink coffee on any other day of the week, so I pretty much hate life for every other day except for today. But the good thing here is that I can guarantee that I'll be productive on Monday, right? So, like, I'm kind of like a manic depressive kind of a person. And it kind of works out, because, right, so when you're, like, super confident, you get all these crazy ideas, right? And then when you're all depressed, you kind of scale back to reality, right? And then you can kind of find a good balance there. Okay, so the editor, we have these like 16 different tile sets. I don't know if you're familiar with auto tiles, but this is going to be an auto tile editor. So I got some zoom functionality. It is all black and white right now because we want to focus on getting kind of nice geometry before we worry about the color aspects. So I'm going to have my artist design in black and white first. And so right now, you know, I got the zoom controls going, and I got the pan with the right mouse. So it's kind of like if you've ever worked with like 3D programs, I'm trying to keep the controls kind of similar to a 3D program, even though it's just 2D, right? So these 4 subdivisions you're seeing, we're going to make our auto tiles using only 4 graphics. So this graphic up here is going to be the upper left corner. Over here is our upper right corner. Here's our bottom left corner, and here's our bottom right corner. And from these 4 graphics, we can derive all 16 auto tiles. So we're going to use a concept called Wang auto tiles. So let's go look that up really quick. So Wang auto tiles URL. Let's see if we have a URL for that. No, we don't. Okay, I'm going to go Wang auto tiles URL. Okay, so every time I try to look something up and I can't find it immediately, I put it in my shortcuts under these synonyms. So I typed these things, and that didn't get me what I want. Let's try, like, just Wang URL. Nope. Wang GPU gems. Wang GPU gems. Wang gems. Okay, So we're going to just make these shortcuts, and then what we're going to do is we're going to go look for Wang. We're going to go match the whole, actually not the whole word. We're going to go search in our shortcuts really quick because somewhere down here we have it. Yeah, so Wang tiles URL is what we want. And I'm going to take this really quick, and I'm going to throw that in there for you. I'm going to clean this up, though. So this is, this whole path right now is in RAM in my shortcuts. And since I have, like, over 30,000 shortcuts right now, like, every time a shortcut is this big, it takes up a lot of memory. So I'm going to put it in a file for next time. So I'm going to take this whole, this URL is gigantic, right? So I'm going to take it, and I'm going to save it to my URL shortcuts folder. So in my shortcut files, I have a folder called URLs, and do I have an NVIDIA folder? No, let's go, is it NVIDIA though? Yeah, it's NVIDIA. So I'm going to make a folder called NVIDIA. I may have not spelled that right. NVIDIA. Yeah, NVIDIA? Yeah, I got that right. Okay. So NVIDIA, and then we're going to say Wang. We'll just call it Wang. And then we'll full file path to clipboard. And then we'll paste this here. And then instead of paste line, we'll do paste file, right? So paste file is a command that's going to work on this piece of data. And so it's going to interpret this piece of data as a file path and paste the contents of that file next time I try to invoke this shortcut. So I'm going to take that, and then I'm going to go back up to the top, and in my shortcuts, I'm just going to put this right here as well. So paste file. Okay, so let's look at that really quick. So, yeah, so Wang tiles is basically a way to create 16 graphics that represent one tile, right? One tile type. And those 16 graphics will latch together in a very specific way so that we have very nice exterior edges along the clusters of tiles that we're setting down. So I don't think the diagrams in here do it the best justice. Like when you're looking at this, it doesn't really look. I mean, if you're familiar with like this diagram here, it might make more sense, but it doesn't really look like. You might not immediately know what you're looking at here by looking at this paper. So. Auto tiles explained video URL. Let's try this. That's probably not a shortcut. Yeah, I'm gonna put that in my shortcuts. Auto tiles explained video URL. Okay, so I might just be able to type auto tiles explained and get what I'm looking for. Yeah, this thing here. So, this video is actually explaining Wang tiles. They call them rule tiles or auto tiles, but a rule tile or auto tile is just a Wang tile. A Wang tile is a specific type of rule tile. So let's go back a bit. So as they're painting with this tile set, you notice they don't have to select the correct subtile, right? So there's 16 subtiles in this tile set, and it just automatically all latches together, right? You see the nice thick border around this cluster of tiles, right? So basically, each tile is self-aware of its neighbors, right? And the tile renders itself differently depending on what its neighbors are, right? And the way the tile renders itself differently is this tile is going to be dynamically one of 16 tiles of the auto tile set, based on what its neighbors are, right? So the reason why there are 16 tiles in an auto tile set, a weighing auto tile set, is because you can have a neighbor to your left, to your right, up or down, okay? So you can have a yes or no, is there a neighbor to my right? A yes or no, is there a neighbor to my left? A yes or no, is a neighbor above me? Yes or no, is a neighbor below me, right? So those are 4 yes or no questions, which could be represented as 4 bits, right? So there's a bit here for yes or no, a bit here for yes or no, here for yes or no, and here for yes or no. 4 of them, right? So in binary, if we have 4 ones in a row, the binary value of that is 15. And to count to 15 in binary, we go from 0 to 15. So that's 16 total numbers. So we need a total of 4 bits to represent all possible states of what your neighbors could be, when we're just looking at neighbors above, below, and to the right and left. So that's kind of what's going on there. I may have not explained that the best, but basically I'm just trying to do some overkill auto tile engine stuff. I know I showed you some of the technical demos earlier. But yeah, so now what I'm doing is I'm just trying to get a very rudimentary user interface into the code I'm doing, and so I'm just drawing some glyphs so that I can throw them in a texture and just get this working. The glyphs are going to be 1-bit color, so it's either going to be it's going to be a pure black and white. The reason you're seeing colors here is the asset that's going to be encoded into the game engine will be this asset, but then we'll pre-process it in bitpack all these glyphs together. But the first part is, right, so when we bitpack these glyphs together, we'll just say black is black. Black is a 0-bit, and then any color will end up being a 1-bit, right? So this will be 2-bit color for this 0, right? Or sorry, I said 2-bit. I keep on saying 2-bit when I mean 1-bit. So 1-bit color, right? The bit can either be off or on for this 0, right? Now if we only use 1-bit color, well, a pixel is 32 bits. So that means we can encode 32 different glyphs within this 8x8 pixel region, right? And so this right here is an 8x8 glyph area, so that's 64. So that means we're going to need a 4x4 area here, a 4x4 glyph area to encode all of these glyphs once we bitpack them together, right? So we're trying to just compress the data a little bit is what we're doing here. So LMNO, and this would be a P. So I'm just going to I'm just drawing out some very basic glyphs. I don't really care. I'm not really going to worry that maybe these aren't the... We're not worrying about the artistry here, right? We just want to be able to look at it and be like, oh, that's a P, right? QR... So this is an R. So I don't even care about capital and lowercase. There's only going to be capitals. Or maybe I should just say there's only going to be one case. And if it needs to be capital, we'll render it like in a different color or something, right? Or maybe we'll put like a little square around it or something. QRS, and this will be T. U, okay, so this is a V. In our V, we'll do something like that. Try to make it not look like the U at all. Okay, WX, no, it's X, Y, and Z. Did we get this wrong? QRSTUV, WXYZ. God damn it. It's like I don't know my alphabetical order. I gotta say it. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so I am off by one here. Okay, so W, X, and this would be a Y. Copy. Okay, so let's take this little black right here and use it to fill over this for a second. Let's just fill over this. We can know where we are. Let's change the color we're painting with. Okay, W, X, Y, Z. X, Y, Z, pretty easy, right? X, Y, and Z coordinates. Pretty easy to remember. And then change the color again to something else. And that looks kind of ugly. It's all going to look ugly. Actually, that looks a little bit better. Whatever. Let's not worry too much about it. It looks ugly. Whatever. Okay. So, the reason we have all this extra space here is because we want a power of 2 texture, so 32 by 32 wasn't quite enough. 64 by 64 was the next power of 2 in pixels that we could use. And we have this extra space. Also, the extra space can be used for any type of other fancy glyphs, right? So if we want like an exclamation mark, a period, or whatever, we can put those in there at a later date. But for now, we'll just use this, right? So let's just, I don't know, we don't really care what that is. We can just black that out or something. Now we might want to just, for our sanity, for our OCD sanity here, we might want to actually just, actually let's not make that black because we might want to just make things a little bit more of a consistency in terms of the colors we're using. So why don't we just like make that white, sure. And then over here, I'm thinking red versus blue, so red, blue, red, blue, red, blue, etc. And then blue can be the zeros, or the evens, and then red can be the odds, right? So, oops. So let's turn this tolerance all the way down. 7, okay. Even, 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 even. Oh, that's a problem. Okay. So let's do like a darker blue for this row, right? Okay. And then let's do red versus blue, we said, right? So actually, I kind of like magenta better. Right, and then when we go further down on the next row, we'll just make it darker. Right, we'll use a darker magenta, so that right. And I'm just trying to clean this up a bit so that it doesn't look horrendous to me when I'm kind of looking at it. So yeah, let's just keep that going, right? So. Yeah, so, okay, that makes sense, okay. So, God, I hate... Paint.net just gets worse and worse with time, in my opinion. Okay, so let's do this. That little weird... This little selector thing annoys the hell out of me when I'm trying to do things pixel per pixel. It used not to be like that, but in the newer versions, it just gets worse. Okay, so let's use this magenta-ish color and fill these in. Okay, and then this would also be the same light magenta over here. Right, so I have to change the... Okay, then this will be this magenta. Okay, and then we'll use the dark magenta over here. Right, dark magenta. Okay, cool. And then we'll take the darkish kind of cyan, or it's not even a cyan. Let's try to be consistent with our coloring, so we'll keep on using this color even though it's not actually a dark cyan, it's more of a sky blue. Let's just stick with that. Okay, cool. So now we have something where it just looks less ugly. That's all. It's just me kind of like not wanting to look at ugly stuff. And we could make a note we could scribble a note in the region over here, right, for ourselves. And I'm thinking we put it at we put it over here. We put it here, and we say Taudump equals 0 for this, and we just shove it in there. So this has to be this here. Well, first of all, can we get this bit packed into a 32 by 32? Yeah, we can get this packed into like a 16 by 16 if we want, right? So this is 64 by 64. And yeah, I think we can. So we're just going to say, we're going to write a note on here. We're going to write a note and just say that, you know, so we're going to write a note in the margin, and let's use like gray or something. And then this would need to be a white. Okay. So this index is equal to we're just going to set it equal to 0, I think. We can change that later. But for now, let's just say it's in terms of like where we're going to put this in memory. We're just going to say it's going to be 0. Okay, and we're just going to put that in the margin, right? Because we got this extra room, so let's just throw that in the margin to let us know when that happened, right? We can also make a note that the video integer ID is 181 right now, right? So we can make a note of that. And just, you know, write in the margins. It's like, you know, when you're doing like woodworking and you write little notes on the wood before you cut it, right? And those little notes are not going to be visible in the final product, but they're there to help you, right? So we could do the same thing here, right? We could just say, so we could do, we don't really care what the case is here. vid IID. So the video integer ID currently is equal to 181, right? So if I want to remember what video I did this in, I can just say, I can see this little note in the file, right? And eventually we might actually use this for some type of meaningful data. But while we have this extra room, we might as well just throw it in here, right? It's not 188, it's actually 181. And we could also put the time, right? So the time is, what is the time? 1 hour, 12 minutes. One hour and 12 minutes. Well, let's just forget about that. This is good enough, right? If we really... We very rarely go back to these videos. It's just enough that, you know, we know when we wrote this, right? We know when we wrote this. It's on the camera here. I think that's good enough. Actually, no, it's not good enough, because we have enough room where we can do it, right? So we can say, right here, we can say 1 hour. 1 hour. And then, it is, say, 13 minutes. All right, 1 hour and 13 minutes at video integer ID 181 is where we kind of worked on this, right? And so now that's kind of like in the documentation. And I really should have saved this at some point, because this is a lot of work, right? This is probably like a half hour of work. So let's go save this. And let's go to the AAC 2020 folder. Right, and we're going to go into our library, and we're going to go into assets, and we're going to do Taudump, 64 Uirects font 64 by 64. Okay, it's a 64 by 64 canvas, and it's 8 by 8 glyphs. So I'm going to call it Uirects. Uirects font. Uirects font, and then sure, that's a little bit ugly, but sure. Okay. Okay, so now that we have that kind of embedded in here, it's already saved. That does make me a little bit paranoid, though. So let's go open up it back up and hope that we didn't lose anything. We saved it, so I don't know why it said that we didn't change this. So Uirects font, whatever this. Excuse me. Okay. So we got this font now, right? Actual size, pretty small. But we just want something basic where we can see what letters we're working with. And then in this white margin section, we just have kind of like some notes. Okay. So now we want to encode this into our source somehow, right? So to get that encoded into our source, we have to do some pre-processing steps, I believe. So if we look at this script over here, if we go look at this, we're probably encoding assets somewhere. Create build system executable, generate hard-coded PNG assets. So here's our different assets. We're not really named asset 1, 2, and 3, but I guess this is what we've labeled the sections. So that's fine. That's fine if that's what it's going to be. Now the question is, where are these assets? So we go look at, let's go put this over to this side, I guess. And if we go look at our library, and we go look at our assets, so we have the original PNGs, and then we also have these files here, right? So we have the system name, and then we have some explanation about what it is, right? So if we want to keep the same kind of pattern here, we're going to name these files the exact same name as the PNG, except we're going to put naked array, NAK, or NOE for number of elements in that array. And that's how we're just going to do this. So let's take this asset number 2 block, and let's just copy it and create an asset number 3, right? And then within here, we can take this name, right? So this name right here is what we want to do. And so it's going to create, and I'm not sure why it says default data is signed integers, because that's not what it should be. Oh wait, no, this is number of elements. Yeah, number of elements is a signed integer. Yes, that's true. Number of elements, and this is not, this is naked array, right? This is naked array. So this thing that says PNG, that's not true. That's not what we call them. Right, even when we highlight these, we can see here's the PNG, a naked array, here's the number of elements. So okay. Number of elements in the naked array and the naked array. Maybe we should have flipped that around. Because we have naked and number of... Yeah, so maybe we want to flip that around. Maybe we're being too picky here. But the naked array and then the number of elements makes a little bit more sense to me. And we want to have very strict ordering constraints. Stricter ordering constraints than what the compiler would have us do. So we got these two here. Right, we got these two here. So this default data here, it's not going to be that. It's going to be this and this, right? Which is going to be this. So, font 64 by 64, right? 64 is the canvas size 64 by 64 is the canvas size. 8 by 8 is the glyph size, right? So that's, right, so Uirects font, right? So we can definitely tell what we're looking at, and then here we can kind of guess, right? You go 64 and 8 by 64 by 64 and 8 by 8, and then we can kind of remember, oh, that's probably canvas, that's probably glyph. And we may forget that, but that'll be good for now. All right, and so this is the third asset. And now we actually have to put this somewhere, right? So we have this in here, but we also have to go, okay, well, where is... How does that get into the code base, though, right? So if we look at the data, this thing here should be responsible for that somehow, because it's called hard-ass for hard-coded assets. And if we look at it, oops. If we look at it, we can see, oh, PAINT5D default data, right? So what we want to do is we just want to all PNG file assets, right? So that's what this section says. So we're just gonna throw this in here, right? And we're just gonna say for here, not this name anymore, right? It's gonna be we're gonna name it exactly the same as the file, right? Just without the underscore. And then oh, I see. I guess still calling that PNG actually kind of makes sense. Alright. Right, because that's the convention we use, so that when we're looking at this, we can just tell really think about it, we're going to use this, we're going to make these two things, and we're going to use it for the PNG file, right? So let's kind of keep that same kind of note there, right? For, right, so this is for the U32 called PNG, right? And then this stuff here, right, it makes these two things in order to create something of a U32 array. That's called PNG. That's called PNG, right? So it makes these two. We make these two things, and we use it to create this thing. We make these two things. We use it to create this thing. We make these two things. We use it to create this thing right here. Okay, so that's fine. We just want to be consistent when we're writing this, right? So we see this commentary. Okay, so we have these hard-coded assets and the number of elements. We're just going to include the number of elements file for the NOE. And the number of elements is also here, and then the naked array is right here. Okay, so we have a problem which is that holy crap, this is quite taking up quite a lot of space. So what I think is we just want to shorten this somehow. So Uirects, we definitely want to keep the Uirects so we know what system it belongs to. But then we might want to say, like, instead of this, we might want to say might just want to say 64 characters and then 8G, right? So something like that. 64 characters, or 64 64 by 64 pixels and 8 by 8 glyphs, right? So, or 64 by 64 for the canvas. Well, the unit is 64 by 64 pixels and 8 by 8 glyphs, right? So, okay, sure, something like that. So that this can be a little bit shorter, right? So this Uirects font, whatever the heck, blah, 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 it could be this, right? It just makes things a little bit shorter. Because otherwise it's a little bit out of hand. Okay. And then over here, we can do the same thing, right? So this thing here, number of elements, and this is the naked array. So number of elements, naked array. And we can also make a note here. So 64P08G. So, right, so the P is for pixels, G is for glyphs, right? We might also want to say P for pixel like that, and G is glyphs, right? So we know that what the G and the P stand for. Okay, so now that we have this, we got the naked array, we got this. Now, why don't we see a match here? We see a match here, but we don't see a match here, right? This is the naked array, this is the number of elements, and it creates a PNG, right? Holy crap! Oh god. Yeah, I just saw, sorry, I was focusing here. Yeah, I'll show you what I have really quick. I was just working on hard coding some glyphs into... I'm just trying to get a rudimentary UI. I hate UI code, but I need to just create little buttons that I can click. I would like to talk to Hirasa a little bit sometime about how I can integrate their UI library into what I'm doing. But right now I'm just trying to make something quick and dirty and get it working. So I made like a little, just a really just basic kind of glyph thing where I'm not going to worry about uppercase and lowercase letters, right? I'm just going to have, 0 through 9 and then A through Z, just so I can get some buttons that I can find. When I look at the button and I click it, if I ever want to find it in the code, I can just look up the button name I see on screen and I can search the code and find it easily. So right now, what you're seeing here on the left side of my screen is the bash script that is taking the PNG assets and putting it into the source code. So we have this thing called FXDUM, which stands for PNG hex dumper, and it's actually a component of my final engine, but we compile it separately, right? So we take out one of the source files. All right, so you see create build system executables. So any type of bootstrapping that we need to do, we're going to do it by taking out certain sub-libraries of the final executable and compiling them as standalones. So, so right here is where I'm taking the we're taking the PNG hex dumper executable and we're compiling it. Now let me see if I libexe. Yeah, so this thing right here, this C11 file is kind of like a is what I use to compile this library as a standalone. So if we look in our library, right, we actually have, this is actually a sub-library of the main project, but right here we're compiling it as a standalone so that we can encode all of our assets into the engine. So if we look at, so exe, so if we go into lib and we go into exe and look at this C11 file, right? So we have this little define, AAC 2020, FXDUM, standalone only, logging on. So this is like just, there's some kind of ugly stuff so that when we compile it as a standalone, some of the code still works. So we have to make this a mini project, so we have to include all these kind of like library dependencies and all these other library dependencies. And we're using load PNG for some reason. Yeah, that makes sense because we got to actually get the PNG data into the hex dumper before we can serialize it. And then here's the sub-library files, right, that we're going to compile, right? And then, all right, so we're going to make it a command line utility. So in main, we have the argument count and the argument array, and then the result of calling main. And so it's kind of a weird name, right? But we namespaced it, and then we said standalone main. So the idea is that this is the command line function that gets called when it's a standalone. But we can also, in the main project, if we ever have a need to do some command line arguments to the PNG hex dumper while the game is actually running, we can still call standalone main because it's also compiled into our main project. So anyways, I'm trying to get this default data for those UI rectangles. So these sections here need to be named based on the file names. So I'm going to take this here, and I'm just gonna right. It's a cut and paste job, right? So kind of cut, paste, change the variables, right? So this section here is all the PNG file assets, right? So we have the PAINT5D default data 1 and 2, and now we have this kind of glyph set. So hopefully that's all correct. I'll know pretty soon when I start to compile this. Does that all look good? I think that all looks good. Let's go check the file names. So if we go into our assets folder, I renamed this, so let's rename this. The name was just getting a little bit too long. Like we're going to keep the Uirects on it so we know what system it's supposed to go to. But this is a little bit too wordy, so we're just going to call it 64 pixels and then 08G, right? So 64 by 64 pixels, but it's 8 by 8 glyphs. So that's just because if we look at it, right, if we open it up, right, this whole texture is 64 by 64 pixels, 8 by 8 glyphs, and you'll notice this kind of color pattern here. We're going to use 1-bit color, right? So we're going to take this glyph, but in texture memory, we're not just going to dump it into texture memory like this. We're actually going to bit pack it together. So if we use 1-bit color, well, with 32 bits, that means that we can get 32 glyphs, all on a, sorry, for one chunk of 8 by 8 pixels, we can encode 32 glyphs, right? Because we have 32 bits, and we're using 32-bit colors, and we're only using 1-bit color for every glyph, right? So you might see colors here, but that's just so that I can understand the data when I'm drawing it. But basically, black will result in a 0-bit, and then any type of color is going to result in a 1-bit, right? For the final 1-bit color bitmap. And then right here in this white space, I just wrote some notes, right? Because we had some extra leftover space. So I thought I'd just scribble in the margins some important notes, like the integer ID of the video right now, which is 181, and the Taudump, where I think I'm going to put this memory, right? So this is kind of like a cell location within a block of texture memory where I'm going to put this. So that's what's going on there. And I guess I'm going to try to compile this now and see if I made any mistakes or if this gets properly embedded into the engine, right? So we're going to go back to our main build script. We're just going to run it, see if we made any mistakes, and hope that if we did make any mistakes, they're not totally cryptic where I don't understand what's going on. So assets Uirects 64 pixels 08G says it doesn't exist. Okay, so I'm gonna put this up here, and then I'm gonna look at what's going on. So the number of elements thing doesn't exist. So what do we do in our build script? We probably need to change some things around because we kept on changing our mind on what this was going to be. So yeah, this needs to be changed, right? So this right here is going to be 64 pixels, and actually let's go in our library here and look at our assets. Right, so 64 pixels and 8 glyphs, so 08G. And then we want to keep that kind of name convention. We want to just keep that consistent name convention everywhere, right? And, right, like that, right? So we can kind of see, and also we're going to get rid of font, right? So we're going to get rid of the, it's for this thing called Uirects, so we'll just assume that it's a font. And yeah, so we just want to make it a little bit more terse because we have some very strict column limits in our code, so we can't be so wordy about things. So that's fine. Like that should be the fixes we need. So we're gonna make, so this makes this naked array object, which is a U32. It also makes this int32 thing, which is the number of elements. And we use these two things to create this U32 array called this PNG, right? So I want to know that this U32 array represents a PNG file. That's why there's an underscore PNG on it. So this PNG file is going to get hex dumped into the source code, and it's going to turn into this variable, basically. Right, so this variable right here, right? And also you'll see in the comments, I have the exact PNG name right here. So that way, you know, if it's a year from now and I'm trying to figure out how all this stuff is connected, I left myself kind of like a crumb trail to be able to figure out where everything, how are all the dots connected, right? That's really the biggest challenge of code, is just knowing how all those dots are connected. Okay, so that looks like we might be good there. Okay, so the renderer is a little bit different now. So right now everything is black and white. And the reason for black and white is we want to, my artist likes to work from dark to light. So we're going to make sure that the renderer, we're starting to polish the rendering code, and you know how like sometimes like when you're cleaning your room or something, things get messier. Yeah, I think you're probably right. This will actually look like some alien tech. Yeah, like I think you are How do you pronounce that? Sori? Sori Daijin? Sori Daijin? Or Sori? Is that, what type of pronunciation goes on that? Like, is it Sori? Like, are those, consonants paired with vowels, like in a, Japanese? Okay, yeah, so Sori Daijin, right? Or do I have that correct? It's been a long time since I've gone through my, hiragana table. My hiragana and, what's the other one? Hiragana and katakana table. It's been a long time. But let's just go with the first part. Sori. But yeah, you are right. This is eventually going to look like crazy alien tech. So, have you seen this before? Yeah, actually, yeah, so, so I can actually show you. It's been a while. So I had a command prompt, and I do Hungarian notation, like apps Hungarian notation with kanji, and so my command prompt was called T, and then like that, right? Right, and then for I had like another math utility for modulus, and so I think I called it T wrap. It's been a while. No, not that wrap kanji. Did I actually save it like that? No. It's been a while since I coded in kanji. It was called I don't even know. Let me go find it for a second. I'm gonna go look for modulus. So here I can show you how I do that, right? So I can show you how I actually type kanji. So I have a master shortcut script, and it has like over 30,000 shortcuts. And in here, right, these are the synonyms. So right, I type this, or I can type this, or I can type this, right? It's separated with these little or symbols, and if I type any one of those things, it's going to take this file, and it looks like it's going to edit that file, right? These synonyms here are going to take this literal text and paste it to wherever I'm typing, right? So I have these, so basically the pattern here is there's these clusters of lines, and it's shortcut synonyms, some piece of data, and what to do with the data, right? So so you could think of it as, here's the action, or shortcut names, data, and action to take with the data, right? Or how to interpret the data, right? So we're gonna go find that in our shortcuts really quick, see if we can find this. Hope that we don't accidentally dox ourselves, because I may have put, right? I try to keep the important stuff like way off the screen, in case I like am going through here and find something I don't want to show on screen. But, you know, I may be imperfect about that, so there's always a risk, but let's go try to find this. So modulus is obviously something that I have used quite a lot, so there's a lot of shortcuts that reference modulus in here. So we might... Oh, there we go. So wrap around. Okay, so I use this kanji for this, right? So wrap around... so right here. And then we could go to, like, Jisho, right? Like, it's been a while since I've done kanji, so we can go to Jisho, right? Right, so if we forget what the heck we're doing, right? It's been a while because the code is... Okay, so the idea was that if we code with kanji, we can make the code, like, super terse. And then people can't make assumptions about what our code does, right? Like, if we want... So a lot of times when people are using like IntelliSense in a code base, they just grope their way around the code base and they don't really read the documentation. They just kind of guess around and just try to like hack stuff together and get things to work. And I'm like, I'm totally against people doing that kind of stuff. Let's try to design the code base in a way that prevents that, right? So I'm like, well, if we call the class T this, right, it's so cryptic that in order to know what this does, you actually have to go into the class file itself and look at the source code to know what you're talking about. The problem with this is that you have to front load everything, right? You have to like read the entire code base before you can even write one line of code. And I'm like, maybe that's a good thing, But then as I start to think about, okay, yeah, in a theoretically pure world, yeah, I guess it makes sense, but this is the real world, and the real world is dirty. And so reality kind of came crashing down on my dreams, and as I started trying to maintain this and coming back to code that I wrote like, months and months ago, and was like, oh crap, what the hell are all these things? I don't remember what they are anymore. I was like, you know what? We should allow people to make some degree of assumptions about what our code does, because we are human. We only have so much mental capacity. We don't really have the mental capacity to be front-loading all of this stuff before we can write one line of code. So that is why the name is Kanji Coder. Right, so hopefully that makes sense. Now, as far as learning another language, I'm kind of like, I haven't been learning any other languages lately. I can't decide. Honestly, I can't decide. Like, okay, if the United States collapses, what language is the best language to learn, right? Or what language should I learn to get the most benefit to my personal success, right? Like, I don't know what language that is right now. Like, I think Japanese is cool, but I'm not certain on what language would be a good time investment. So I got to think about it. I don't know. Yeah, I gotta think about what language is going to be most beneficial to me. And there's a lot of considerations, like what countries can you be a refugee to and blend in with the population, right? So I'm a white person, so I don't look Japanese, so I would definitely be able to be picked out as a foreigner. So something like Spanish or German might be better, because then I can blend in with the native population as long as I can pronounce without an accent. And that could be beneficial to me. Obviously, that's a little bit political, so I'm going to let you connect the dots as to why blending in would be a good idea. But I don't want to get too. I don't want to cancel myself here or get myself in any trouble. But yeah, so let me run that again, because I kind of like ranted there. But I forgot to ask. Oh yeah. So. Run down. Oh yeah. So I'm gonna go over this. Yeah. Okay. You get me? Okay. Cool. Yeah. But yeah, I don't want to, yeah. I wish everything was, I wish the world was a nicer place than it is, but it's not, so. Okay, so, if you're familiar with auto tiles, this is like an auto tile editor, and the engine is going to have, every auto tile set is going to use 4 tiles. And we're going to actually use the Wang tile auto tile algorithm. So if I find that for a second, weighing tiles. Let me find the weighing tiles algorithm. I don't know. I don't think I showed that to you yet. So okay, found it. So weighing tiles is what we're gonna use. Oh no, that's. Oh, it's fine. It's fine. Yeah, it's fine. I like explaining things, just because usually I'm just kind of like programming stuff alone, without any viewers. And once in a while, you know, Henry throws some people my way. I think that, you know, as time goes by, and this tech gets more interesting and I get more and more viewers, then maybe I'll stop explaining things so much. But until then, right? Until then, I'm not going to worry about it, right? Like, yeah, I'm using weighing tiles, the weighing tile algorithm, with an auto tile set. So the source data here is 4x4 tiles, but weighing tiles, they use 16 subtiles for every single auto tile set. So what we're going to do is we're going to generate the remaining 12 tiles on the fly. So what you're seeing here, this is going to be the upper left corner graphic, the upper right corner graphic, bottom left corner, and bottom right corner. And from these, we can derive all of the other graphics. So you can see, like, if we take a certain subsection of pixels that are on screen, we can find the tile that is touching everything, right? So if we take, like, these middle pixels in here, we can have kind of a graphic that's touching everything, right? If we want an edge tile, if we want a right edge tile, we can take kind of these pixels, like, over here, et cetera, et cetera, et cetera, right? And I already have all the math figured out for how I'm going to do that. Now, the nice thing is, there's other ways you could do this, right? So I believe there's a thing called, what is it called? It's called Fang Autotile. Yeah, so there's a thing called Fang Autotiles. It also does this kind of thing to generate autotile sets, but it uses a different set of base graphics. I need to work on my Win32 code there. So I can actually, let's go find that for a second. So I just want to check the search results. So if I do fractal autotile engine, still not on the top, but I'm trying to get my stuff on the top here. But Fang Autotiles. Yeah, so this thing right here. So making auto tiles is just a pain. It's a pain, and so because it's such a pain, they have. Oh, what's the end goal? Okay, yeah. So actually, yeah. Let me explain the end goal. I'm gonna throw this in here so you can look at this. Right. So this is an auto tile generator code. Is an auto tile generation system, and so I want something like this, except the auto tiles are generated on the fly, so you don't even need this workflow, because you just create 4 graphics and the engine handles the rest of it. You don't have to manually tell the engine, hey, compile these graphics, right? Oh god, there goes my bitrate. So first of all, I'm going to throw that in there, and I will yeah, I'm gonna type more things out for you, but let's go look at my demos, and I'll show you what the end goal here is. And I know that some people who have already seen this are like, think I'm probably a broken record by now. Okay, so I made this game. It's like Bomberman, except the bombs explode in different directions. The bombs are proximity mines, and the bombs don't block your path, right? So I don't know if like Bomberman is the best way to call it, because there's so many differences. But like if you ever played like old GoldenEye, okay, so one bombs, one vertical. Yeah. So, right, so there's these different bombs, right, explode in different directions. So I should probably actually make a note of this. So I would like to, since I'm not talking, I do want this to be a log of what I'm up to. So I'm going to put this in here for now. Yeah, so have yeah, so actually, let's do that. Let's do that right now. Okay. So we're gonna find the So let's try to find that folder. Old AA1 GIFs. Yeah? Close. This is what I need. Okay, so we're going to upload these to Imgur. Yeah. Okay, so, Did I already, I forgot if I showed that one or not. Oops. Six. Not sure if I... That's 6, so we want 7 now. Yeah, so... I'm gonna try to get through all these, I guess. Just so that that way I have it kind of like permanently on here. Let's open up this 8. But yeah, yeah, testers really liked making levels with this. Oh! So, I got a lot of notes. Okay, so, let's see, this one, let's go throw that in there as well. What else we got? Let's just try to get the first, 10 in, right? Do we have like an even number? Yeah, let's try to get, 9 and 10 in here, right? And then I'm gonna stop adding images once I get to the 10th one, because I'm gonna start working on more of the code, and you know, I just gotta get. Okay, so there's this. And then we have the 10th one. So I'm going to upload the 10th one, and then I'm going to be done with this, and I'm going to go back to coding. But yeah, this is... but yeah, this... I have to get an Ethernet cord because this stream is unwatchable right now. This is unwatchable, and this has been happening to me like every single day. Every single day, this has been happening to me. And I used to, like, I didn't want this to happen to me. I used to be hardwired into the router, and now I'm not, because everything got moved around, and now my cord does not reach that far. And my mom gave me like this crappy Ethernet code, so. Oh, cool. Oh, cool. Um, let's see, is this the last one? Is this the 10th? Yeah, this is the 10th.
you off the video for a bit?
No, I'm just not talking because I don't have enough bandwidth to talk without being,
Can I vacuum or not?
sure, yeah.
Just got a little to
The hell? Where'd my back button go? Oh, I see. Oh, wait. It's up here. Hey, how's it going? Looks like my bandwidth just got a little bit better. Yeah, so I had some other people here, but the bandwidth kind of sucks, so most of them dropped out. Because Heroes kind of send me some people. I was kind of quiet. The bandwidth was in the red, so it didn't make any sense to speak, because I figure constant buffering while I am speaking would be kinda hella annoying. So I figured, since it was buffering, since it was buffering earlier, I was like, you know what, I'm going to just stop talking, and if I need to say anything, I'm just going to type it. So that's what I was doing. So right now, I'm going to show you this, but I'm just making a gallery of the first 10 GIF images of the old game and explaining what the different things do. And then after this, I'm gonna get to coding. Yeah, I don't know, maybe people are checking back in since the stream kind of sucked earlier. That's my guess. I'm gonna guess that people are kind of like checking back in, right? Because Henry sent some people my way, but the stream bandwidth kind of sucked, so I'm guessing people are just kind of like popping in and out, is what my guess is. So let's see, this is the first level of the game. Falling tiles. Called Firen, or Falling Iron. What else? So yeah, falling iron here. If it hits a bomb, that bomb immediately explodes. Falling iron falls in a stuttering pattern because the gameplay exists on a grid and all the explosions are on a grid. And if the iron were to fall in a completely fluid manner, it would be harder to comprehend how the puzzle should resolve as chain reactions occur. Some testers have found this highly annoying, and unprofessional, but I'm keeping it this way because the integrity of the gameplay is more important than fluid visuals. Also, try to keep... Okay, so, you know, also, we want to keep in mind here that when you're designing a game, you don't want to try to satisfy everyone. You want to... you want people to be highly divided, right? So you don't want to satisfy everyone. You want to have a whole bunch of people who really like what you're doing, and then a whole bunch of people who really hate what you're doing. You don't want to try to satisfy everyone, because then everyone is going to be meh, right? No one's going to really like it. No one's going to really hate it. You're just going to be meh to everyone. Keep in mind that good game design should be both. Enjoy. If you try to set... Okay, so let's throw that code in there. Also, flame pistons. Pistons that emit spark flame when pressed. Gameplay. Okay. So what is this? A list of testers for the original Atomic Alice #1 game. About 800 of them on newgrounds.com. Trying to check in every once and a while on Newgrounds and get some of my old testers watching me on Twitch. Having a lot of testers makes it very time-consuming. Yeah, clickety click, clackety clack. Yeah, okay, I'm almost done here. I'm almost done. So I just wanna like, let's shamelessly self-promote ourselves here, right? Let's just, bam, throw in the explanation. Like we're not even gonna put it at the bottom, right? So we're always just gonna be like, boom, put it in there, right? This thing here, oh, AI can also trigger bombs. Notice that certain materials leave behind a scaffolding when they are destroyed. This is so that when entire level Hey. Right, okay. So basically, when you're destroying the level geometry, you want to make sure that the destruction never soft locks you, right? And so if you're careful with what materials you choose, when certain materials are destroyed, they leave behind like a climbable scaffolding, right? So it's like the wreckage from the destroyed level can still be climbable, right? So you see this like ladder type that's kind of being emitted when this geometry gets destroyed. And then also this blue material is indestructible, right? So if bombs blow up over there, you can still climb it because it never goes away. Other materials completely perish, right? So there's like this vine material right here. When that gets exploded, right, it just completely goes away. So as you're trying to code the level, or not code the level, but as you're trying to design the level, you want to make it so that you can get from point A to B even after all the destruction has happened. Now, that's not the only strategy, right? You could make it so that if you don't get to the exit door in time, you just get blown up, right? But you want to make sure that the level is designed in such a way that you don't get soft locked. So that can be kind of tricky, but a good level design should not soft lock you. So let's go over here. So good enough explanation. Seizure warning screen is pragmatically generated. You must follow the instructions to get into the game. The idea here is that in the unlikely event of a seizure, the person playing the game would have had to have read the warning in order to have progressed into the game. Okay, yeah, so Atomic Alice gifts. So we could also say, let's put the code stream here. Am I not paying attention? Maybe I'm not paying attention. Or maybe with the stream reaching me, yeah, there's probably a delay. Here, I could put it down here. Here, let's go. Here, let's throw this over here for a second, and we can find out. Ooh, that's not good. I'm gonna have to put this up here for now. Almost ready. Yeah, try typing something while that's on screen and see what the delay is. Now, it could have just been that I wasn't reading your messages in time, right? Because I'm trying to do this, and sometimes I'm a bad multitasker. Okay, so that's up there. So we're going to take this. And, okay, cool. So, I don't know, it could be, we see the bitrate is blue right now. Okay, so anyways, we got this all done. We got this all ready to go. All right, so we got a nice little gallery here. And I'm gonna post this, and then I'm gonna share the link. So, I got all these nice explanations about what all this is about. This is the first 10 gifts. We're gonna post it to the community, and maybe we'll get more people interested in our stream because we're posting kanji coder like on each one of these. We should probably do One of these is green, is not green. We should probably do like https:// and then I think we have to go cut and paste this. There we go. What URL failed to upload? What the heck? What the hell? I don't know what that was about. Okay, so that's fine. This is good. Let's go post to the community. I have a love-hate relationship with Imgur because I post a lot of things that people hate, and then sometimes I post something interested. Post publicly. Okay, so we're going to post this publicly to Imgur, and then hope not too many people downvote us for being stupid. Okay, so yeah, we got this nice little thing. Let's go take that. Let's post it to here, and then let's post this in our notes. So old AA1 GIFs URL. So I got to make a note of what I just did. So, oh, there goes my bandwidth again. AA1 GIFs 1 through 10. AA1 GIFs 1 to 10. AA1 GIFs first 10. First 10. First 10 AA1 GIFs. First 10 GIFs. Okay. Alright, we'll put that in there. Auto tiles explain video URL. We were just there earlier. I think I called it auto tiles explained. Yeah, this thing. Yeah. Okay, so let's put these shortcuts back over here. How do I play? Oh yeah. So Flash game, but you. Yeah, let me go find it. Let me go find it for you for a second. So, so Flash is dead now, and so it doesn't work in any of the browsers. So, well, actually, it might work in Torch. I don't know if Torch discontinued Flash. It's a Chromium-based browser, so that worries me. But it might work, and it might work. I don't know. So let's go search for it. Let's go search for this old game that we made. Yeah, so we never quite finished this game. A lot of stuff is just, yeah, launch a Newgrounds player. So yeah, unfortunately, so I took all those GIFs before Flash was officially discontinued because I knew this. But yeah, you can try to figure that out. Yeah. Also, yeah, you also need the password in the comments. But yeah, let me go put this back up on the top and start writing some more code. Yeah, so I want to keep writing code. But this streams. So yeah. So I'm not holding it against anyone who dips out here, man. I mean, most people already dipped out, but I totally understand dipping out because the bandwidth kind of just sucks right now. It's like going back and forth between a good bitrate and a bad bitrate, and this is really gonna hurt me if I want this stream to get popular, right? Like, I can't be having this kind of bandwidth issue, and that's why I'm kind of like, I don't know, what is it? Hold on. So, there's a shortcut I want. You will blame everyone else. Okay, so while I'm here, speaking of the problem I'm having, where I'm saying, oh man, the bandwidth sucks, well, we should take some personal responsibility for this, so self-sabotage, war guy, blame. Let's go find that for a second. Blame kanji. Let's go not use that as a kanji anymore. Let's go to our kanji. Blame. We're just gonna go in here, and we're just gonna make an entry. Blame -k, blame k, blame _k. Alright, and we're just gonna make this over here. And then we'll go back to the top of the file. Backwards direction. Let's start from here. Blame, pick, blame kanji, blame MMA fighter. So there's a talk by this like MMA fighter who kind of talks about people's propensity to self-sabotage themselves. So I think that would be a good thing to keep in mind as I'm kind of like feeling like I'm being self-sabotaged. Well, or that you know, when things go wrong, you tend to blame it on other things besides yourself. So I think it would be important to remember that it's my fault. So let's go for you will. You will own nothing. You will die. You will fail. You will tell me everything. You will figure out, I think, is the thing that does it. So let me go look at if that's the URL I want. I think it is. So if I go look for you will figure out. So I believe it's like figure out a way to blame everyone except yourself is what this is. Yeah, this one right here. Okay, so
them more than anything else.
Okay, yeah. So this is good stuff. So let's put that in there, right? So, hey, take a look at that. That's pretty awesome stuff. And then I'll put it in here, right? So I'll go, right, so let's just take this URL, right, youtube.com, watch, and let's just paste it in here. So that next time we're looking for this, we can find it a little bit quicker, right? MMA blame, MMA blame, MMA. How about MMA blame? And then also the thing is, this is really good talk. It's such a good talk that if I don't already have it saved in my hard disk, I'll probably want to do that as well. So I don't think I have. Okay, so what we're going to do is we're going to take this URL thingy, and we're going to go backwards direction. We're going to go up to the top of the file. And we're going to save this, right? So anytime I, like, see all these little timestamps, like, I watched this video, and I transcribed it quite a lot, because I thought a lot of this stuff was very interesting. So we're going to say, vid, MP3, MP4, underscore MP4, underscore MP4 capital. Right, so we're going to take this kind of thing here, and we're going to just go, we're gonna go find this. So YouTube makes it really difficult to download their stuff, because they want to keep you on their platform. Let's go YouTube downloader. Now, Torch used to be able to do this. Torch browser used to be able to use this download button and download YouTube videos, but something about it now keeps you from doing that. So now we have to use this YouTube downloader. I'm going to put this off screen. So that's the video I want. 720p. Do we really care about having high resolution? We just really care about being able to understand it. So we're going to use like we're going to just download the smallest file size because we just care about the audio. We don't really care about the visuals. It's like we just want the information. We just want the information for the future, right? So in our, let's go find our video folder. So non-vital, educational, YouTube, and then year 2021. Okay, so what did I get wrong here? Non-vital edu, non-vital assets, oh, is it vid edu? Yeah, it's vid and then edu. Edu vid YouTube 2021. Okay, yeah, so here we go. I'm gonna go save this in my little archive as video number 035 and mma.mp4. And then I can put this in here, right? So it's this thing, and this is the file path. Okay, cool. So now we have that, right? So the idea is that whenever we take copious notes, whenever we spend like hours and hours, like I literally spent hours and hours like watching that video, right? It's a 3-hour video, and I'm like transcribing it as I'm watching it, so that anytime I see something interesting, I can like, you know, reference it. But now what happens when, you know, that video gets deleted off of the internet, right? Then we're in some trouble. So we don't want to make that mistake. So to avoid that mistake, we or not mistake, but to avoid that misfortune, I guess, we need to copy it to our hard drive so that that doesn't happen to us. Okay, so anyways, that's there. We're good with that. Let's run this project, make sure that it still compiles, and then we'll focus on doing the rest of this stuff. So make sure it compiles, and then we'll work from there. Now, hopefully this recording is fine. The recording, I think, is going to be intact. It's just the stream sucks. Okay, cool. So that looks good. Let us continue now. So we're thinking that this is going to go in Tau Depot slot number 0 here, right? So Tau Depot number 0. Let's just make a commentary here. Now, how do we want to do this? Do we just want to, like, it might be a little bit easier if we just make these slots twice as big, right? And then we can just right, like we make these slots kind of like this. So let's diagram. So what we're thinking is, you know, we have something like this, and is that so we're thinking that this is Uirects, and this is 0, right? So we're thinking something like that, but maybe that's a little bit too big, right? So maybe we want to just make that a little bit smaller, right? And right, so Uirects is 0. Right? And then for the unallocated, we'll just make those little dashes, right? And let's just do this. Let's paste this a few times, right? So paste, oops, paste that there, paste that there, oops. Okay. So in this like layout here, right? Unallocated, unallocated, unallocated. And this one is called tau, right? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so we might want to make a note here. 0, 0, 0, UIR, user, Uirects. Okay, and then over here, this on the very bottom, that is tau, which is tau depot, right? That's what that memory is for. So it's like what thing controls that memory, right? So tau depot kind of controls that memory. Well, this is kind of self-referential, right? Because tau depot is here, and this is Uirects. Let's not worry too much about that. Let's just keep on, right? This is 15. And then, do we have enough room? Free spot. So unused. So 1, 2, 3, 4. Oop. 4, 5, 6, 7, 8, 9, 10. Okay, so 10. We're going to have to throw this up here a little bit. 10, 11, 12, 13, 14, and 15. Okay, and then we'll just take this. Right. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, 10. 11, 12, 13, 14, and 15. Okay, so we got this stuff here, right? These are unused slots, and this is Uirects, right? So this is dex tau allocations. Reservations. Dex tau reservations, right? It's what's reserved for what, right? So we can say, we can diagram this as DexTau reservations. We could also call it DexTau reserved, right? So if we want to be a little bit more shorthand about it, we could call it reserved. Or we could also call it DexTau RES for reserved, like that. Right, so we have different ways in which we can reference this, right? So this diagram here has multiple names, so that when we're looking at it, if we want to reference this in some code, we can, if we're running out of column space, we can use this long-handed version, right? So the other thing is we can go into our documentation. So we can go open up the hashtag documentation. So in our documentation file, we have this kind of thing here. And we can just put this here, right? Or maybe not like that. But we could post this here and make a note of this, right? So we can just say DexTau res, right? DexTau res. Right? And we can make a note of, like, what the heck is this about? What the heck is this little crazy diagram we're doing? What is this all about? So video ID, and let me move this over so I can see what video number and whatnot we're on, and the timestamp here. The video ID is 181, and the time is 3:23, 32. Sure. UIR section reserved. So at this time, I created this section that I'm going to reserve for glyphs for creating UI rectangle fonts. We have a lot of unused sectors in the Taudump memory. Let's try to use the top level cell 0 to store Uirect font glyphs. Okay, so that's what we're going to use that for. And as far as like what the other allocations are for, also thinking, so another thing I'm thinking is that when we're looking at this, I'm thinking that we have a division between these things. Okay. I'm thinking, or actually let's do dashes. So I'm thinking that we have these two columns. As we're trying to figure out what to do with this memory, because we have a lot of extra memory, I'm thinking we have static memory, and then we have dynamic memory. Right, and then I guess we might as well write it like that. Let's divide this, right? So I'm thinking like it's something like this, right? We have two obviously different columns that are for the different kinds of memory, right? And then, right? So as we're trying to figure out how to use this memory, I'm thinking static memory here. This is memory that once it's set, it's not going to it shouldn't change. And then we can use this section for dynamic memory. And so that way, if we have dynamic memory and want to update all that dynamic memory at once, we can just go, if we want to do a mass update of all the dynamic memory, we can just draw a rectangle here and say update all these pixels, right? And in the same way, if static memory for some reason needed to be updated, we could just say update all these pixels, right? And that might be kind of nice. So I am thinking that as well. So do we have enough room for this to put this over on the other side? I don't think we do. We could try to make this diagram a little bit smaller. There's not quite enough room to push this in, is there? Yeah, there's not quite enough room. Maybe if we tried to make this diagram a little bit smaller, right? If we tried to if we tried to kind of shorten some of this stuff and just say Uirects, and then I could say, you know, UIR like that, maybe, and this would be tau, right? So maybe if we're lucky, we can shorten this a bit enough to where we can kind of like visualize it, where we can condense it enough to where it's on the same row as the other diagram. I don't know if we're gonna be able to get away with that, but we can try. Let's just try and see what happens here, right? So we could remove this, right? We can remove this over here, and then now tau needs to be rewritten, so tau. And then we can also remove this little gap here, right? And we can keep that double divider so we know what's going on there. And we can split that in half. And now we have to clean this up a bit. So maybe if we draw it like this, we can have a quick little schematic of everything that needs to be here. So static and dynamic. We can abbreviate dynamic as dynam, right? So we have these two different allocations, right? We have static and dynamic, right? These are the two different kind of columns. Sure, now if we do that, we might be able to just squeeze it down in there, like right here. Just be like, bam. Ooh, very close. What do we get wrong here? Control X. Let's give it a little space. Okay, let's try this one more time. Oh, this just got... It's really close. It's really close to getting it all in there. But we're gonna have to... what are we going to have to do here? I guess what we can do is we can get rid of the extra spaces here, right? That is kind of ugly because it's no longer square, but at least it will help us. I don't know, I just like having everything condensed so that we know what we're doing here. Yeah, so static and dynamic, top level cells, right? All right, so these are the top level cells. And so this thing, these are top level cells. And then we also could put that in here, make a note of what we're doing. So we have the uncondensed diagrams in here if we want to see them. So they're in multiple places. There we go. So now we got a nice little diagram here where we have some more. We have another little diagram to show us kind of like what stuff is used for. So we have this tau thing, which is the original tau depot for the different systems. The original top level allocation storing dynamic variables for the various editors. Okay. So when we're looking at tau, right? I'm looking at tau in this diagram right here. What is that all about? What are we storing, right? Okay, and that's just called tau. Okay, Uirects, UIR, Uirects, it stores, stores glyph map for basic font so that we can render rudimentary UI within shader code. Right. Okay. This is static memory. Okay. So let's do an at static. Let's call it dynamic for dynamic. Okay, and then over in our hashtag documentation, let's make a note of that, right? So, at static memory, and then at dynamic memory, and static and dynamic, pretty kind of basic ideas here, right? And we're going to just make a note of, like, what do we mean by that? What the heck are we trying to say? Okay. And at static memory, texture, tau, texture of memory that should not be changed after it has been set. For example, the glyph font used by Uirects system. Okay. At dynamic memory, right? Tau texture of memory, that is dynamic. And changes often during editing gameplay. Editing or gameplay. Should use commands. So if we're doing this, then in Tau Depot, if we look at Tau Depot functions, we should be using Tau Depot put, Tau Depot get, And then we have a tau sync, so let's go look at tau sync. So not this function, this is the OpenGL call, texture push. The main thing we care about is tau sync run. It looks like tau sync run, that's private, so there must be a public version. Well, that's an assumption, there might not be. Tau sync run. Oh yeah, AAC 2020 folder. Let's go look for that. Find all. And see what we got here. Tau sync run. Is there anything outside of tau sync? Because there should be something in... Oh, right here. Tau sync run. This is capitalized. Dry or wet? Yeah, so this is the thing. Okay, so over here, most important notes. So let's make a note here, right? So we have all this boilerplate. It'd be nice to just know, when we open up the file for the functions, what's the most important stuff that we want to know about these functions? Rather than being thrown the boilerplate, what's the most important stuff we want to know? Wet. And if we look at tau sync functions, or not tau sync functions, tau sync data, we should have a variable called where the hell is this? Oh, I see. Unit tests. Wet run for production. Okay, got it. That is pretty wordy, right? But yeah, we might want to say that, you know, right? Use this to resync to GPU every frame. Right? So this is the most important thing we want to use, is this tau sync wet run thing. So I'm making a note of that so that we have that for the future. So tau depot put, and so we also wanted this stuff here. We're not going to worry about what's in there because it's just too wordy. Right, so there. So we got this static memory, dynamic memory kind of notes. And then also we might want to make a note that's dynamic memory. You know, so if we, right, all these little synonyms, right, that lead us back to here. Okay. So the next thing is, we've made these notes, and that's good and all, so we know kind of what we're doing. Yeah?
When you have a chance, I got 2 cartons in the trunk of the T-Bird.
Okay.
Racks I need to put in the basement.
Okay. Alright. Okay, let's make sure we can still compile, and then we're going to figure out how we're going to encode the... How are we going to load this into the system, right? How are we going to do that? So we need to, like, somehow initialize this. And so the initializer for the Uirects should not be in a init none function, right? So I think we made it in an init none function. Actually, no. We didn't. We don't even have it in the system yet, right? We just have the... right now, we just have Uirects data, right? And we have this idea of how we want to do this. But we don't actually have the textures, right? So... So we have one glyph, and this glyph is going to be 32, or is going to be 8 by 8 pixels, right? So that's kind of what we've decided on. That one glyph is going to be that size. Eight by 8 pixels, 1-bit color. Right, black or white. Okay, so that is the way we're going to do these glyphs. And so the next thing we want to do is go in new. You can just say AAC 2020 boilerplate paste, something like that, right? And it says use NSSBP paste. I'll eventually remember what that's supposed to be. And we're going to go in here and we're just going to paste things. Now this thing that says init none, we're going to change that. That actually needs to be an init function. And to do bitpack glyph assets into Taudump memory. Alright, so we need to do this. We'll make a vital error message so we don't forget to do this. We'll call this uirects.f for functions, right? And then we're going to go through here and we're just going to replace all this stuff. So this is uirects, and some of it needs to be lowercase, some of it needs to be capital. So we'll tackle all of the lowercase stuff first. And then we'll tackle the uppercase. Okay, so now that's in there. So now we have the boilerplate. We have the boilerplate in here. And we want to go into the silence system and add that, right? So silence data. And the Uirects, I have no clue where this is going to go yet. So, hello. How's it going?
I am very depressed.
Okay.
This one is the...
Then Jake, would you like... Here you go. There, I made you a bed.
It's a pitiful offer.
It's a bed. So I'm just trying to figure out how to just put in stuff together, making some glyphs.
Oh shit, sorry, are you streaming?
Yeah, I'm streaming. My bandwidth sucks though, everyone left.
That's unsurprising.
Yeah, no, yeah, it's not surprising, yeah.
The internet sucks.
Okay, yeah. It used to be fine, I don't know what's going on. Yeah, it used to be fine.
Did you set up that Ethernet cable?
No, my mom gave me this Ethernet cable. It's like chewed up with some exposed sections of wire. I'm like, I'll put that in my bucket of cords, but I'll probably never ever use it. I actually want an actual heavy-duty Ethernet cord.
Yeah.
I gotta find my wallet and figure out where my ID is, because it's not in my little armband things. So It's like It's somewhere, but I gotta find my bank account balance to figure out how much money I have so I can buy one of those cords.
We're supposed to be getting our stimulus checks this week.
Yeah, I gotta file my taxes before I'm not
Kinda,
gonna
yeah.
get. But yeah, I gotta figure that out. But yeah, I made some glyphs. See, check this out. See, in my library, I got this assets folder.
Yeah.
And then in here we got Uirects, right? If I double click this, right? So it's just a 64 by 64 graphic
Yeah.
with like, you know,
I see.
you get the
Yeah.
idea. So this is already kind of 64 by 64 pixels is kind of actually a big chunk of memory for the memory footprint that I'm kind of going for.
Well, yeah.
So what we're going to do is we're going to take this and we're going to use 1-bit color, right? So for 1-bit color, it's either black or white, right? A 1-bit for white, a 0-bit for black, right?
Mm-hmm.
And so even though you see colors here, that's just so that I can right, there's no borders or anything. It's very densely packed, so without the colors, like the 2 and 3 would blend together, right?
Yeah, I got
So the black becomes black, but then any color becomes a white pixel. So we'll convert this to a black and white image and then encode it in the memory. And then because everything is 1-bit color, that means we can take 32 glyphs and we can smack them into the same bitmap on top of each other. Mm-hmm. So within one 8 by 8 pixel section, we can get 32 glyphs because we can bit pack them all together and use all 32 bits. And so the pixels is like a big stack of images, right? 32 layers, mm-hmm. 32 bits in a pixel, right? And so with that, there's more than 32 things here, right? 26 plus, actually no, wait, 26 plus 10 is, oh yeah, 36? Yeah?
You tell me.
You're the math major, 36, right?
Yeah.
Okay, so 36 overshoots 32 by a bit, by 4, right?
Mm-hmm.
And so it would be nice to pack everything into like this little 8 by 8 section. Mm-hmm. And we could if we only had 32, but we really kind of need 0 through 9 and A through Z at the very minimum. Mm-hmm. So we're going to have to scan through here, and what we're going to do is we're going to pack everything into, instead of an 8 by 8, we're going to pack it into a 16 by 16.
Okay.
Right?
I like you, but I can't stay down here.
Okay. All right, so you're going to stay in trouble.
I kind of want to die.
Okay, don't die.
I mean, don't tell me what to do.
Okay, see you around.
Yeah.
Okay, so anyways, let's figure this out. Let's figure out how we're going to do this. So I don't know where this needs to go in terms of the overall hierarchy of the systems. So well, let's look at this. So Uirects we want to put somewhere. And the first thing we realize is that, oh, you know what? Uirects is going to be used by different systems. So GPU view, it'd be nice if GPU view could know about the Uirects, right? Now, like GPU texture wire up. I don't know why those are two separate things. Oh, because we got to look at different memory blocks. Fragment shader common. Like in here might be good. But definitely before GPU view. Definitely before GPU view because we want to be able to we want those different shaders to have access to What about, do we have tau frag? Tau frag is in there. Yeah, so I think over here it kind of makes sense. There's no exact position where this has to be, but we want a place that makes sense. So I think that, I don't know if Uirects would ever need to reference fragcom, but fragcom really is common code that really shouldn't even be able to access Uirects, so it kind of makes sense there. But GPU view should definitely, yeah, so I think it kind of goes here. Okay, so then what we want to do is have some order enforcement, right? So we're going to say in Uirects data, right? We'll add some extra order enforcements. So I'll add an order enforcer in here. Uirects PAINT5D tau lock P5D Uirec 1. Tau lock so we have this thing, but we also have define AAC 2020 Uirects Uirects Taudex right. And then over in tau, let's go open up tau for a second. Tau depot. MISC section. Tau depot tau whatever. I'm gonna just make this 0. It's gonna be this tau here, right? So it's gonna reference backwards, right? Sure, like that. Uirects Taudex. So here's the top level allocation for the static data. And right now we're at vid IID 0181 and the time is 03:56. And then how about 13? Keep it a lucky number. So this is going here. And then the order for enforcer, we're going to say that if and go into libchan for a second. So in libchan, when we look at the top file, we have a thing called like include blah blah blah. So So these things, these includes here. Um, um, and it's not going to be this. It's going to be, if we look at the system here, right? Fragcom is the one we want to look at. If not deft, so make a note here. Fragcom should come before Uirects, right? And then also, if, and we'll go look over at the list of things here. If GPU view, right? Oh, GPU view doesn't get to access this memory directly like that, does it? So actually I changed my mind. The Uirects, the GPU view doesn't actually know about this abstraction because it's an abstraction that exists on the Tau. So Uirects, the Tau needs to know about the user interface rectangles, right? Or is it the other way around? Are the Uirects kind of built on top of the... I guess Uirects was referencing Taudump, so it's built on top of Taudump, right? So actually, anything that's Tau, we're gonna put it after that. Something like that. Yeah, Uirects, I guess, goes here. My bad. So include... So Taudump, GPU view. So Uirects should come after Fragcom, right? So if this is not defined, then we have a problem, right? So if ndef. Same thing with GPU view, and same thing with Taudump. So Taudump. Tau Depot. Okay, so now let's change this to should come after. Let's try to write that in a way where it's not as bold, right? So we can see these two things here. Uirects should come after fragcom, GPU view, etc., right? So these things here, we can highlight them and be like, bam, 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 right? So why is it this way? Why? So let's make a note of why this is. So common fragment shader code should not know about something as specific as user interface rectangle. Right? Okay, and then for something like this, GPU view can look directly at the texture memory, but it should have no knowledge of what each pixel of that texture memory is encoding. Thus, it comes thus included before Uirects library, right? So we just want to write all of our justifications for why certain things are included at the time at which they're included, right? So Tau Depot Uirects grabs a Tau Depot, grabs a top-level Tau Depot slot for itself. Well, to make the connection obvious, the Uirect defines are set up by reference. We have a line. So to make it obvious in Uirects data, right? So if we look at Uirects data, actually it's this thing right here. This line right here. Right. Which necessitates that Uirects comes after Tau Depot in inclusion order. Okay, and then also, if we're doing this, let's look at this. It might as well Tau dirt type sync and frag. We might as well do all of them, right? So So I'll make a note here after any Tau system. Right, Tau depot. I gotta take a bathroom break. So Tau depot, Tau dirt, Tau type, Tau sync, Tau frag. And let's make a note. The previous constraints mean we should make sure Uirects is included after any Tau system, right? Now make a note of this, at vid IID, right? So 181, and the time is 4 hours, 8 minutes, and let's do 32 seconds, right? So that's kind of like why we have this here like that. Okay. So if def, etc. Okay, so we have some order constraints, right? So, so we could make a note of when we set this up, right? So, actually, no, we can't put a multi-line in a multi-line. That'll create problems. Oh, and we already did. We did it over here. So we got to change that. So, we can just change this to triple quotes if we want, or we could do this. My bad, but yeah, we can't be putting a multi-line within a multi-line. The C compiler will hate us for that, so let's make these single-line comments within here. And I'm already wrong because this is the order enforcer. The order enforcer actually does not belong inside of a multi-line comment in the first place, does it? It doesn't. So my bad all around here. I don't know what I'm doing. So this order enforcer should not be in a comment section at all. Actually, we could, though, if we want to explain the section that we're currently in, we could do that, right? So, so at vid IID, so 0181, time is 4 hours, 9 minutes, 9 minutes, and 10 minutes, 10 seconds. The exact order of our dependency list does not matter in AAC 2020.c11, but there are certain relative orders that do matter. The orders we really care about have been specified here. If this order enforcer section becomes too distracting, we can offboard it to a separate include file, right? So we can put this in a separate include file if this gets distracting, right? Because there's a whole bunch of junk in front of stuff, which can kind of like make things kind of hard for us, distracting for us. So we'll take that into account. So we have all these things, right? So if this is not defined, right? If this is not defined, then it means that we're including Uirects before this, right? If GPU view is not defined, then it means that we're including Uirects before that. If Tau depot is not defined, it means we're including Uirects before that. And then here's all these other Tau systems that should also be included after any Tau system. So Uirects should be after any Tau system, and then here's the specific error message, right? Okay, so now that we have that, we need to do some more work here, right? So in our list here, right? We're trying to figure out where this went. And we've changed our decision a few times, but it looks like it's going to end up in here, right? So we'll fix this eventually, but let's just stub this in like this for now, and we're going to fix that. But we want to get things compiling first. So it's after tau frag is where it's going to go. Now, did we also make a note of tau frag in our order enforcer? So if we look at our order enforcer in the data section for Uirects data, do we have tau frag in here? We got fragcom, we got GPU view. Tau frag is not in here, is it? So why is it going to go after tau frag? Let's justify these. Well, tau frag is a tau system, that's why. Tau frag is right here. Okay, cool. So that's good. So in the silence system, we're going to go find tau frag right here. We're going to duplicate this. Oops. Oh, no, that worked. It's just our syntax highlighting goes crazy sometimes. And we're going to go Uirects, right? So Uirects is going to come after tau frag. And then we need to go find tau frag here, right? Duplicate this. And Uirects, right? So user interface rectangles, right? User interface rectangles. That's what this is, right? Okay, so now that that's kind of stubbed in there, we just need to give it a run. There's still more work we have to do to get this working, but let's just give this a run first. And then we'll have to start getting ready to go to the shop soon. But let's try to get, okay. So this is running, cool. And so now the next thing is we want to stub more of this code in, right? So if I close this, the silent system is good. We gotta keep this for reference. The libchan is what we want to work on. So libchan is going to go over here. So in Uirects, we want to keep the functions here. So we want to eventually get some initializer code in here for how we're going to set this up. But before we do that, we just want to stub the system in, right? So if we go open, let's go open libchan top and libchan bottom. And then let's also open up f macros, because we're going to have to look at that as well. Okay, and we're also going to have to look at the functions file. So if you go in main, here's the main functions file. Here's the main kind of place where everything's being called from. So in libchan top, the first thing we need to address is that we've added another system. So this max is now 52, right? So these numbers match here, right? Okay, so the next thing we need to know is, hey, we have tau frag, we have zoom common functions, and then we have Uirects right here, right? So okay, so Uirects should just be a data-only kind of system, but you never know, right? So what we can do now is we can find Uirects in here, right? So close to the bottom of this list, we should have Uirects. Or not Uirects, but tau frag and zoom common, right? So here's tau frag, here's zoom common, and here's the place where we want to make that insertion point, right? So we want to take tau frag and we want to duplicate this whole cluster. But now, instead of this being tau frag, this is going to be Uirects, right? And then this is going to be system number 45. 45, that means this is 46. Okay, this is 47. This is 48. This is 49. This is 50. This is 51. This is now 52, right? We're just incrementing everything by 1, right? So not too much work because when we're inserting this, the numbers didn't have to be moved up by too much, right? The closer to the end of the list we do this, the less work it is to stub things in. But we still want to stub things in the most sensible location. So the amount of work it is, right? We don't want to just stub everything the closest to the end of the list to avoid this extra work. We want to put it where it makes sense, even if where it makes the most sense is the most amount of work. User interface recs. Okay, user interface recs, right? So then we want to, right, we did this here, right? We have to go down to this next section, which is all of the function files, right? So we include all the data files first, and then we include the function files. And so we see taufrag and we see zoom common. I don't know why zoom common isn't all highlighted like this, but there we go, we can do that now. And we see that the taufrag has a lot of weird stuff in it. So we're going to take the zoom common this time, right? And then we'll rename this stuff to taufrag. Or not taufrag, Uirects, right? And Uirects is 45, so the 45 is already good here. But now this is 46, right? Zoom common is now 46. And then we just have to add 1 to everything that comes after. Right? Okay, this is 50. Okay, then I got 51, and then I think 51 is the last one. No, 51, 52. Yeah, there we go. Okay, cool. So now that we have that, we can close this one and look at libchan bottom. And libchan bottom has some other checks to make sure that everything is in the correct order, right? So you'll see all these systems in a very specific order. The order doesn't really matter in this file, but we want to keep it kind of the same as this file just to make things easy to manage. So if we look at this, we can look at taufrag, find where taufrag is. It's right here. And then after that, we got zoom common. So the insertion point is right between here, right? So right between here is where we're going to insert this. And we're going to change it to, we're going to change this to Uirects. Right? And this is just a redundancy to make sure that everything is included in the correct library chain order. Okay, so now here we got another redundancy. Right, so we got a lot of redundancies because there's no way to write unit tests for what we're doing. And so in order to combat that, we have a lot of redundancies to make sure that everything is included in the correct order. So this will overlap this 44 with the other 44 to make sure that everything is in the correct order, right? And then we will have to make an insertion here for number 52. Right, okay, now we can move on to the next section. So in here, right, we have taufrag and zoom common, so we're going to duplicate this. We're going to rename this one in the middle to Uirects. And we're just undeffing this, right? We're just undeffing this so we don't pollute anyone's preprocessor if they include our library into their code base. Okay, that's good, excellent. So what's next, my friend? Well, we can close this and we can look at F macros. And we decided that we actually do need some initialization logic. We need some type of pre-processing because we're going to like bit pack these graphics. So in here, right, the next thing we want, so we got taufrag. So find taufrag. Here's taufrag. Here's zoomcom. And they have init nuns, but inside here, this is going to be an init. So let's erase that, so it's an init function, and it's Uirects. So it's like data only. It's like a data only class, but it needs some initialization for how that data gets set up. Okay, so 52. Okay, so now that we have this, what time do I have the shop today? Did I already miss it? Monday, 7 p.m. No, I'm still good. Okay. So Uirects init right here, and I think that's all I need for this list. So this is the bottom file. Okay. So in the top file, we need to look for number 43 might be shifted around. So tau sync. Oh, tau sync is still 43. Excellent. But PAINT5D is now system number 51, so we want to change the spot check here. Okay. Just a lot of redundancies to make sure that, so this is our init none functions. These are, we don't want to change these. We want to make an insertion in the initializer code. So in our initializer code, it's before PAINT5D, but it's after Taudump, right? So if we look at here, Taudump is here, then there's Uirects, and then there's PAINT5D. So Uirects goes right here. Uirects goes right there. And then we can highlight these two systems, right? And we know that the color needs to be between these two things, right? So if we find this, here's the two things. I think it's going to be easier just to cut and paste this and just be very careful about it. So anything that says Taudump is going to be Uirects here, right? So Uirects, and this is Uirects, and anything that says Taudump here is Uirects. So this is Uirects, this is Uirects init, Uirects init, Uirects init, and Uirects init. So, right, so now we have this section of just Uirects, right? So Uirects, all this stuff. Okay, cool. So now that macro function is in where it belongs, and then we also have it in this list, so if we need to dynamically rebuild this code later, we can. I'm not going to update this list because I'm sick of updating this list, and it's not guaranteed to be up to date anyway, so I can ignore that work. And I'm going to. So now the next thing is we got to go look for taufrag in here. Right? Taufrag is initialized before Uirects. So if we look in here, here's taufrag, here's zoomcom, right? So we want to make an insertion point between here. So we're going to duplicate this, and we're going to call this one Uirects, and it's going to be an initializer function. And then we're going to alter this checksum, right? So there's 52 systems now. Okay. And then the next thing we want to do is we're going to go here, and here's the actual code. So this right here is the actual function that we're going to call, the macro that wraps that function call that we just made in the comments. So Uirects, right? And this is an initializer, so it's going to be init. And then we're going to put an X here. So the X is actually still is a macro for 0, but it just makes it so that we can easily look at this column of zeros and X's and know which one's an initializer and which one's an init none, right? Okay, so then also this checksum here, we should just be able to, if we did this correctly, we should be able to take this checksum right here, and we should just be able to paste it right here, and everything should be hunky-dory. Yeah, so there we go. Boom. Okay, so now Uirects is 45. 45 is Uirects. And we've already made a mistake because P51 OGL blah blah blah, that is 52. But if we look at Uirects, that is saying it's 45. So, oh no, 45 Uirects. I don't know why I thought I was looking at 46 or 44. How about up here? Uirects 45. 45. Okay, yeah, we're good. Never mind. Okay, so you notice that we have all these macros here, and then over here, these are not macros, but it says Control F help, and it says do not extract. It's just because to make the code more linear without a whole bunch of bulky noise, and just have a linear list of all these functions, to make this happen, we had to wrap it in a macro because these functions in this big list here may or may not exist depending on what library chain we're compiling up to. So speaking of what library chain we're compiling up to, we need to compile up to the top of the library. So we want to compile up to 52, which is PAINT5D, right? So you want to compile the entire library, right? So if we compile the entire library, all these functions exist, right? But if we only compile up to poly OGL here, then only these functions exist and these functions don't exist. But we wanted to write it in a way where we could just keep this nice linear list without guarding it with a whole bunch of if-defined macros, right? So those if-defined macros are hidden in the fmacros file, right? And then to reduce some of the trouble caused by the indirection, where if we search for where these call sites are, in the code, we're never going to find them, right? So since we're never going to find these call sites, which could make it very hard to comprehend how the code is connected, we make this control fhelp section to help alleviate some of the problems caused by the indirection from these macros, right? These macros are causing a level of indirection that can make it very hard to figure out where the heck these are being called from. And so this control fhelp is going to help alleviate that problem. It's a little bit hackish, it's a little bit ugly, but it'll help us. So, okay, so we have those init none functions stubbed in. So I think we're ready to give that a shot. I think we're ready to compile and just see if we can get this to compile, right? And then if we can get that to compile, it's 5:30. I might want to like take a shower, 6, 7, do some. Okay, so air. Uirects after any. Okay, so let's look at this for a second. Is this the data file? Yes. And the error we're getting. So if we look at Uirects functions, right? We made the not functions. If we look at Uirects data, we have. Oh. Oh, well, these things aren't right. These, no wonder. Okay, so my bad. So, right. I just screwed that up, right? That's what they need to be. Okay, I see what's going on there. Okay, let's give that another shot. Right, so at least we know that that guard will actually be doing something, right? It's not like it doesn't do anything. It actually does serve a purpose to have some more strict order enforcing. So, right, the code is just very rigid, right? And that is by design. We don't want flexible code. We want very non-abstract code where we can kind of find our way around what we're doing here. And my scroll wheel has failed me. Okay, so obviously the okay, let's not worry too much about it. We have some bugs in how our controls work. We'll worry about that later. Okay, cool. So everything is kind of stubbed in. And so what we're going to do is we're going to do a git bash here. And we're going to do git status, git add dot, git commit dash am, Uirects stubbed. Okay. So we can focus on the initialization step now. So we can So now that Uirects is here, we can use TauSync to do a force update of the texture memory, or we could use Pixel Pusher as well. We could use Pixel Pusher to update the memory. There's many different ways we could make this happen. But the first thing we would need to do is we need to use the asset dumper, right? So so let's go look at dump ass. Okay. And within here, dumping assets into callocked memory. Okay, so it looks like we've decided that the asset dumper itself is responsible for this. So we're saying, you know what, this data is going to exist no matter what we're compiling up to, huh? Is that how we've kind of decided this? Dump as PNG. You know, if that's the way we want to centralize this, I mean, that's fine. So the problem with this is, oh, pixel array, pixel width, pixel height. Okay, so what we're going to do is we're going to steal one of these, right? We're going to steal one of these asset dumping functions. And then what we're going to do is, what is this called, right? Like, what is this piece of data called? And if we look at our bash script, we can see that we called it this thing here, right? So we're going to take that name, and anywhere we see orange, we're just going to find and replace, right? So anywhere we find orange, we're just going to find and replace. And okay. And this function here needs to be changed as well. So this PNG002, it's not PNG002, it's to pixel array, and that pixel array needs to be a different size than what the other things we have. So we could just call it PNG3, I guess. I mean, let's just give them kind of like, let's just give them serial numbers based on what they were in the first place, which is kind of like, maybe that's not the best way to do it, but let's just, for uniformity's sake, let's just call it PNG3, right? So PNG3 is this thing. We got this pixel array, pixel width, pixel height. We need to make sure that the references can be never null. We don't want to override it if it's already in use. So we want to make sure that we're giving it an allocation that doesn't already have valid memory there. And then pixel array, pixel width, and pixel height. We want to create these variables so that we can fill them out with this function here. And that function is going to return the deflated size of the deflated array data, and the width and the height in pixels of that data, right? And then we have a check here, right? If we take the width and the height and we times it by 4, we're expecting, you know, exactly this. But that check is not going to be valid in this case because for this embedded asset, we're not going to go with the 512 by 512 because it's just that asset doesn't need to be that big, right? So if you look at the library and we look at the assets, the asset for this is like a 64 by 64. Right, so if we look at this in the detail, 64 by 64 pixels, the bit depth is 24, because we're not really using the alpha channel. So all we're going to do is we're going to say, you know, 64 by 64 times 4, right? Pix width times pix height times 4, right? These should be equal, right? So not 64 by 64, right? So the problem is it's not 64 by 64. And then this right here, so this asset is not 60, and this is PNG3, right? PNG3. Okay. Okay, so we might want to make a note here. Hashtag pattern breaker. Trying to keep all assets exactly 512 by 512 pixels. But this asset is going to be put into a subsection of Taudump memory. And also, this memory is not I think it's called this. I could be wrong. So let's go look at Pix name for a second. Taudump CPU Pix. So first of all, is this the best name? Should we have named it the other way? Because now we're going, this almost looks like specific to general, the way we wrote it. Oh no, because it's the system and then the specific part is what category of information is. I see. So that's fine. But in our hashtag section, we might want to say Taudump, PAINT5D, so this is so the correct names for what we're looking at are going to be something like this, right? They're actually right here, so we could just steal them here. Hashtag, CPU picks miss. So we'll just name this section CPU picks misspellings, right? And then that way we have this kind of note here, right? So next time when we're writing notes and we accidentally spell it wrong, we have a way to, if we look for this thing in the code base, and we're like, why can't I find this thing? It's because we spelled it wrong, right? And it'll lead us to here, right? So if we search for something and we don't find it, it would be nice to know why, right? So sometimes we want to facilitate being able to search through the code base easily, so we'll do that to help us. So we were going to write a comment here, yeah. So this Taudump thing, right? So we did this, right, into being into 1-bit into 8x8 1-bit color bitmaps that are stacked in stacks of 32 for each sector of 8x8 pixels. Okay. So yeah, we just want to keep a note of this, right? So the pattern breaker So we also want to make a note of, well, what is the pattern breaker in this case? In case we accidentally like cut and paste this code somewhere else where it doesn't actually belong, we'd like to know what the pattern breaking applies to. And in this case, it applies to the Uirects asset. Okay, so dump asset number 3. A little runtime check to make sure that asset is exactly 64 by 64, right? So the video ID here, 0181, time 04, 45, and let's do 13, right? So, right. Right, so if we want to come back to this, we know why this check exists. This check exists, once again, because this asset right here is a 64 by 64 pixel asset, and that's the way it's designed. The other assets we have are kind of like bigger, right? So the other assets we have are bigger. That's fine. Okay. So now that we have that, we have this dumper kind of thing. We had some other helpers, right? So there's some helpers where we okay, so we convert this into a pixel array, right? And then we copy it into pixname. That could help us. So the location at which we want to paste this is a little bit different, though, right? So so we might want to make a helper here, right? So So let's say, so we need a thing that kind of dumps an asset into a subsection of 512 by 512. And we're going to want I'm actually surprised that this doesn't actually do any of the initialization. That's fine, I guess. So okay, so we're going to want to reference the array and the length. Do we need the width and the height? So I think we need the array. So I'm not sure what kind of the signature of this is, but we need something like we need something like examples. So I want to take these hard-coded assets that are kind of embedded into the source. And then also we want, I think for now, pix width, now this asset dumper, where is it? So if we look at the asset dumper, it comes after pix name? Okay. So we can say so just a generic helper. We take the number of elements, we take the width and the height, right? So this would be example pix width, example 64, right? Pixel height, example is also 64. And the CPU pixels, the example here for CPU pixels would be, if you look in pix name, we're going to specifically use Taudump, right? So now we're running out of room, so we'll have to just remove that redundancy, right? So the examples. Okay, and then we also need a Taudump location, right? Now, depending on where this is, we might not be able to put this here, right? So Tau Depot is actually down here, right? So, for this to happen, we got UI frag. We're gonna have to make a Taudump. So this is Tau frag. And in here, do we want Tau Sync to know about this? Maybe. Does the fragment shader code need to know about this? Maybe. I see we have Tau sync with GPU. This says Tau sync with the GPU. This is not true. It's the Tau fragment shader. Do we want this to have access to syncing? Maybe. It would be nice because then this system could, after we dump the asset, we could instantly sync. Could create problems for us. Does the fragment shader code need to know about this stuff? Maybe, I don't know. Okay, so I'm thinking that in terms of where this goes, I think Taudump goes here. Okay? And so we were thinking of kind of like creating this little helper for dumping in a subsection. We're going to cut this, though, right? And it's going to go in here. So about, let's make an about section for this and say what this is for, right? So we're making a section for this, for dumping stuff into Tau. Okay. Uses memory into a okay, so if we're gonna do that, then oh, okay. Okay, so we're still gonna make this here. We can still put this here, because it's gonna take CPU pixels. But it's going to take a U32. These are going to be int32s. And this is an IO8. Okay, so U32, I32, Let's just steal all these things right here. And then we'll undef them. Okay. And we'll just call this void AAC 2020 dump ass oh wait, this needs to know about a tau memory region, right? Change my mind again. This is gonna be Taudump. So we want to know what these memory pieces are called. This part, though, is going to be implied, right? So, alright, so we're going to dump memory into a subsection of the tau system. Right? Uh, 0459. Okay. So let's call this tau dump. Dump is 4, tau is 3, 4 plus 3, 7, dot functions, dot underscore. Okay. So we got a nice little thing kind of set up to figure this out. So the CPU pixels is we can just keep this variable here like that. Sure, why not? And so we have the width and the height. And then we also need a tau dex. Want a tau dex, and then within the tau dex, we need so in tau, let's look at tau, the tau system for a second. Right? So we have this tau dex, right? So we have one of these things, and they're 128 by 128 allocations. And within here, we have all these different cells that we want to paste into, right? So we're going to have to each one of these things is 32 by 32, right? So the tau dex is a UO8, and the subdex is also a UO8, I believe. Taudex, subdex. And if you want to select multiple places to paste this data, what are we going to do here? So it may span more than one cell, right? So we'll assume that when we're doing cells, they can go like this. We can select here to here. We can select here to here. We can do any selection. So we're going to have to define two cells and then draw a rectangle between them, right? So okay. Okay. So we're going to take those indexes. Right. Okay. Right, so if we want to find where this is coming from, right, these are subcells, and these are partitions. We got the pixel width and height. Right? Okay, right, so we have this kind of thing, right? So it's the width and height of the U32 array, right? Okay, so this is a lot of stuff, right? So we might want some input checks. So the first thing is, how do we get the upper left corner, right? So int32 x0 equals, right? And that's going to be so times each one of these sectors is a 128 by 128. So plus subdex x. In each of those cells, or each one of these cells right here, is a 32 by 32, right? this is the top left of selection rectangle. And then over here, it's going to be x and y, except it's going to be the 1s. Okay? And it's going to be dx and dy. But then instead of sub x0, this is going to be 1s, right? So so this is the mins and this is the maxes, right? And this is a 1 here as well. So we'll take this region, right? This will be the top right, and we just want a width chk equals x0, x1 minus x0 plus 1, and then we need an int32 height check, y1 minus y0 plus 1, right? And if width chk not equal to pix width, then air 2021 0315 6:11 p.m. A. Sure, something like that. It just needs to be a unique error message, but I don't really care what it says. Height check. If that's not equal to the pixel height, then we also have a problem, but instead of the width being wrong, that's the height that's wrong. Okay. So, size, pixel dimension checksums, right? That's what this is. Okay. And there's some more stuff we need to do, but I need to take a break. So we're going to try like a 20-minute break. I'm going to try to do the... Actually, I'm going to do a 30-minute break, I think. And then 30-minute break, and then we're going to start getting ready to go to the shop. So 30 minutes, get ready to go to the shop. Actually, 20 minutes. Let's do a 25-minute break. And we're going to have to clean up this stuff, get ready to go to the shop, and we'll write more of this code while we're at the shop and do a code review when we get back. Okay, so set this for... Okay, I'll be back. And that's not right. Okay. God damn it. Okay, I gotta get going. Yeah, I have to head off to the shop. Okay, so before I go, we got this code in kind of unfinished state, and I realize that in here we need this thing called Taudump, which we're working on, and then down here we have Uirects. I almost feel like Uirects should really be... Let's look at Uirects here. So why do we say we're going to come after this? Oh, because it uses the Tau system. Okay. Okay, I see why. Because with the dependency order, the GPU view system... Okay, So the shader code is going to need to know about Uirects in some capacity. So I think putting it here might be good, right? So let's not worry about the GPU view system that, you know, doesn't have... It's a rudimentary... GPU view is a rudimentary editor. No. Okay, so yeah, in here we're gonna have a thing called so you have the Uirects, and then here we're gonna say UI frags, fragment shaders for different user interfaces, right? So we're going to create a section for the different fragment shaders for the different user interfaces here. Taudump is going to go here, and then where's the thing we just kind of made? Oh yeah, Uirects is right here. So there's a lot of stuff we need to figure out, but we'll figure that out. We'll push this up to our repo so that we can get this ready to go to the shop. So I'll be right back. Alright. Let's connect this. Okay, let's fix some stuff on our repo here. So in this Git folder, in the utility patents, in our models, there's something that we did. We got the wrong names for these PNGs because Inkscape is stupid. Yeah, I got this PDF.pdf thing because Inkscape does not recognize the capital extension. So we're going to rename these to the proper extension type. And then we're going to sync up our utility patent repo. Overall, we're just going to get ready to get out of here. And this index refresh thing is sucking. You know what? This is probably because my horrible bitrate. That's probably what this is about, now that I realize it. I didn't realize why this was happening, but now I realize it's happening on every single repo that I've been working on, where it's just like refreshing the index forever. So this is kind of infuriating, actually. Okay, I have to go now. God fucking damn it. Okay. So, index refreshed. Okay. Okay, so we push that to origin, and then we still have to git pull. Come on. Escape, colon, right quit. Different hard drive or different disk, so. Okay, so now that we got that, we also want to push up the current repo. So this thing here is a broken commit. Okay, user interface work, it's a broken commit. Push it up to GitHub. We're not going to push it up to the public because it's broken. Right? Okay. Okay, now that's now that's up to date. We're going to close all this stuff here, right? And we're just going to have to reopen it later. We want to go look at our thumb drive that we're going to take to the shop. It's called multi-boot. And the most important thing we want to take is the utility patent. So git bash here. And we're going to do a git pull origin master. Or something like that. And then while we're waiting for that, we might as well go over here to the AAC 2020. Put this on our thumb drive as well, right? So already up to date. Okay, sure. Git pull origin master. This should not be though. Is it origin master? I did a git clone, so that should be called origin. Okay. So now we wait patiently for this to check out, and then it's like already 7 now. God. Actually, no. Okay, cool. So that's all up to date. We're ready to take this to the shop and get out of here. So I'm out of here. Later.